What's up guys, welcome back to the channel. Today in this video we'll be solving this previous question paper that you see here. So this is a national certificate mathematics N4. So this question paper here, it was actually written on the 22nd November 2003. It's an X paper which it was actually written at 9 o'clock to 12 o'clock. So usually it takes 3 hours for this type of question paper, and it consists of 100 marks. So the entire question paper has 100 marks, and it has 5 questions in most cases. So guys, I'm gonna do all the questions, and you will choose which question you are interested to watch. Remember, there will be a timestamp on this video, so if you don't want to watch question 1, for example, you can click on the timestamp of the question that you're interested. Let's say, for example, you are interested in question 4. You don't really have to watch the entire question paper for whatever the reason. Maybe you don't have time to watch the question 2. But if you are interested to watch the entire question paper, you can just watch the question paper in a sequence order. Alright, so we're gonna start with question 1, and then from there we continue and do other questions. So this is question 1. As you can see, the first question here, which is question 1.1.1, they want you to draw a graph here. So first of all, you need to know what this graph is. So what I'm going to do here, I'm just gonna copy this question and put it on the side, and then we start solving it. So let me just do the copying and let's start solving. Right, so this is actually the question from the question 1. So this is 1.1.1. so they want you to draw this graph. Guys, before you draw this graph, you need to understand what type of a graph is this. So from the first thing that I know about graph is I look at our variables here. We have x squared and y squared, and this is equaling to 1. Now look guys, this is actually an ellipse. So if you don't know what an ellipse is, it's supposed to be a graph that has a shape like this or a shape like that, right? So it's more like a circle, but not really, more like a American football shape. So it's supposed to look like this, or a rugby football shape. Okay, so this is how it looks like, right? So there is a general formula for this type of graph. So let me first write the general formula so that I can explain it from there. So we have x squared over a squared, right, plus y squared over b squared. There we go. And this is equaling to 1. So this is actually the general formula for the ellipse. So all you need to know guys is that a is an intercept of x, and b is an intercept of y. So it's supposed to be equaling to 1. So as you can see, the one that is given to us here, it still has the coefficient of x and y. So you need to get rid of this coefficient of x and y in order for us to draw this graph. What's so nice about this is that we can actually simplify this. So we can say 4 divided by 4, we're going to be left with x squared. But then on the denominator, we can say 100 divided by 4 is going to give us 25, right? Plus, now we go to the next step, which is 25y squared over 100. So 25 divided by 25, we have 1 multiplied by y squared. 100 divided by 25, this is going to give us 4, right? So this is equaling to 1. As you can see now, look at the general formula. We have x squared divided by a squared. So meaning here our a squared, x squared divided by 25 is going to be 25, right? So we need to solve for a. So we are not looking for a squared, we are looking for a. So a is going to be square rooted. So we square root a, we're going to have a, and then what is the square root of 25 is plus or minus 5. So for a we are fine, we managed to get it. What about b? Now we are looking for this b. So we know that b squared here, what is dividing y squared, is usually 4. So in order for us to get actual b, we must square root this, right? So when you square root b here, it's going to be plus or minus, what is the square root of 4? Is going to be 2, right? So basically this is our intercept. So we know that a is an intercept of x and then b is an intercept of y. Just in case you don't know or you can't remember this, it's very simple. Once you know the general formula, just know that a is dividing x, so it's going to be the intercept of x. B, which is dividing y, is going to be the intercept of y. So now we know that at x we're going to intercept at plus or minus 5, at y we're going to intercept at plus or minus 2. So let's draw it here. It's time for us to draw a graph. So when you draw your graph, guys, do not forget to do the dots here. All you have to do, you do the dots and then you start connecting. All right, so it's time for us to connect. So I'm gonna try to connect. It might not look exactly like the ones that you see there, but as long as it is intercepting on the right values there, okay, even though it doesn't look good, let's stick to the one that we drew here. But as you can see, it looks like the one here on our left. So basically this is the correct answer, as long as you show your intercept, your y-intercept, your x-intercept, and also you get the values for those intercepts. So this is out of 3 marks. I hope this was not that difficult for you guys. Just in case you didn't know how to draw this graph, this is how you draw it, guys. Okay, how do you know this is an ellipse? Whenever there is a plus here and then it's equaling to 1, just know that this is an ellipse. Okay, they can trick you, but this one basically it's straightforward. You didn't need much to simplify. All right, guys, we are done with question 1.1. It's time for us to do question 1.1.2. all right, guys, before we do question 1.1.2, so by the way, this is question 1.1.2. let me just highlight it for you guys. Let me just highlight very quickly. This is the one here, right? This is question 1.1.2. But before we do it, I would like to say don't forget to subscribe to the channel. Also don't forget to share this video with your friends. So I'm gonna copy this question again because they want us to draw again a graph. Okay, guys, so I already copied this question. So they want you to draw the graph that you see here, guys. Look, if you look at this graph, it kind of looks similar to the one that we just did before this, but it's really not the same. So how do you identify these graphs here? When you look at this one, these two terms are separated by a negative sign there, while the other one, the two terms were separated by a positive sign. So be very careful, be very careful. So when I look at this graph, this is actually a central hyperbola, right? So we have two types of central hyperbola. So let me show you the general formulas for central hyperbola before we continue. Again, I'm going to show you how do they look like. So I'm going to write those general formulas in. So we have a general formula for this one where we have x squared over a squared minus, notice there is a negative here, and then we have y squared over b squared. All this is equaling to 1. So how do you know, how does it look like? So this is how it's supposed to look like, this one. Let me just write very quickly, because in general it's supposed to look like this one. X and y, it's supposed to look like this. Since our x is positive, it's supposed to intersect at x like this, right? And like that, right? Then there is a line that's supposed to, there are two lines that are supposed to cross here from the origin going that way. So I'm gonna try not to drawing this. There are two lines that are supposed to go there. I'm going to explain this later, but basically this graph that you see here is supposed to look like this. I hope you guys can see this, right? And then we have another one where we have y is negative, is positive. So another one, it looks like this. They're still all central hyperbola, by the way. So we have this one, we have y squared minus x squared, but then they are also divided by the same a and b there. Y is divided by b squared, and and then the x is divided by a squared. So it's also similar. So this is also a central hyperbola, guys. As you can see, what separates these two terms, it's the negative sign. Once there's a positive sign, it's no longer a central hyperbola, it's actually an ellipse. So we have to be very, very careful because they look very similar, guys, right? So how does this one look like? I'm just going to try to draw it here. Since y is positive here, this one here is going to look like that. It's going to intersect at y. So let me first draw my lines here, the line that are going straight like that and the line that are going straight like this, right? There are two lines that actually this graph must asymptote at, right? But these lines, they are also passing at origin. Hopefully I'm going to try to explain them way much better. So this graph here, since y is positive, it's going to intercept at y and it's going to look like that, right? There we go, asymptote line, and it looks like that. The asymptote to this side, and then there we go. I hope you can see, guys. I hope you can actually see. It's trying to make a straight line. You don't want to make a straight line, you just make it curvy, right? So this is how it looks like. As you can see, we have two different graphs here. They are actually both central hyperbolas, but this one here, let's start with this one. When it intersects at x, it means that our x is positive. When it intersects at y, it means our y is positive. Be very, very careful. Again, when you see negative between these two, just know that it's a central hyperbola. So let's look at the one that is given to us here. All right, so look at this. We have 4x squared divided by 36. So if we simplify this one, I'm just going to do it here at the corner. We're just going to have x squared over, because if we say 4 divided by 4, we're going to have 1 multiplied by x squared. We're fine. What are we going to have there? We're going to have 9. There we go. We're going to have 9 minus, right? All right, so let's look at y there. So if you say 9 divided by 9, it's going to be 1 multiplied by y squared. That is going to be y squared divided by, what is 36 divided by 9? It's going to give us 4. And this is equaling to 1. Right. So basically, that's how you solve this one. That's how you simplify this one. Again, don't forget, look, same as our ellipse, we are dividing, x is divided by a squared and y squared is divided by b squared. So do not forget that. So meaning here, our a squared is equaling to 9. Now if you're looking for a, we have to square root both a squared and 9. So the answer is going to be plus or minus 3. Right. So let's look for b. Remember, b is the one that is dividing y. So b squared is the same as 4. So when we're looking for b, we have to square root these two. So our b here is going to be plus or minus 2. Right. So basically, these are the ones that we have here. So since we know this is gonna intercept at x, so we know that this, our graph is gonna look like this, meaning this part here is gonna be x. But then how do we get these lines here? the lines that are actually our graph asymptoting at. How do we get them? There is a formula. It goes like this: y is equal to plus or minus b over a multiplied by x. So basically, when you substitute this is the same as plus or minus b. What is your b? Is going to be 2 over 3 then x. If you look at this graph here, these are actually straight line graph, guys. These are straight line graph. If you know your straight line graph, as long as we don't have c, remember our c is 0 here, as long as we don't have c, our graph is gonna pass at origin, just like these red lines here that you see here. I hope you can see them though. I hope you can see them. So I'm just gonna erase this and create space for us here. So you're gonna write your Cartesian plane. I'm gonna try to make it bigger, this one, because I want you guys to see what we are doing here. All right, so we have the 0 point here, we have the x-axis and the y-axis. Make sure that you show the axis as well. Then from here, look, this graph here, we have the one that is positive. So the one that is positive, let me just do this. I just want to make it to be dotted line. Let me just try to be as accurate as I can be, guys. Okay, so it's passing at the 0 point there. So this one here, we can say this graph here, we can say this graph here is equaling to y is equaling to, if it's like this, the gradient is positive, it's equaling to 2 over 3x, right? And then the other one that is gonna go this way, let me try to make it that way. Guys, you can try to use the table to draw this graph, but look at the marks. The marks are so low, there's no need for you to do that, guys, right? So this one here, the graph is actually negative, is equal to negative 2 over 3x, because when the gradient is negative, the graph is going to lean this way. When it's positive, it's going to lean that way, right? So now look, what did we say at the beginning of this question? We said that if x is positive, it's going to intersect at x. So where exactly, what is the point at which this graph is intersecting? So this graph is going to intersect here at 3. Okay, let me just change the color here so that you guys can be able to see. As you can see, it's positive 3 and negative 3. So let me try to put it here. Let's just say this is negative 3 and that one is positive 3. So our graph is gonna intersect here, right? So these lines here, we call them the asymptote lines. Okay, they are straight line graphs, but they are asymptote line, and they're always passing at the origin, guys. Okay, they're always passing at the origin. So how do you do it? So this is how you draw your graph, guys. Hopefully we're gonna be able to see it. Okay, as you can see, this graph of yours, it shall not pass this asymptote line. It should asymptote on this line. Never ever pass these lines. Okay, even this side here, the graph is supposed to look like that. Okay, even this side here is supposed to asymptote here. Never ever, guys, don't ever cut this asymptote line, because that's where they will see that you don't know what you're doing. Okay, so as you can see, this is our graph. Look at this graph. This graph now, central hyperbola that is given to us. It looks like this for this central hyperbola that is given to us here. I hope, guys, this makes sense. I hope you guys understand, because if you don't understand what's so nice about this, you can always watch this video over and over again. I know it takes time, but I needed to explain this, because some people, they confuse this formula and they think it's an ellipse or a circle. It's not a circle, it also is not an ellipse. So guys, I hope you understand. If you don't understand, rewatch this video, and also you can ask questions wherever you think you don't understand. Right, it's time for us to do the next question. So before we do that next question, do not forget to subscribe and also share this video. Like this video as if this helps to understand better. All right, we are done with 1.1. Now it's time for us to do 1.2. Now 1.2 is actually word problem. We are done with graphs. Now it's time for us to do the word problem. So we need to find the value of the new length and width after the area is being doubled. So we're gonna read the statement here that you see here. So this is question 1.2. So again, I'm just gonna copy this question and paste it somewhere else so that we can focus on it. But this is 1.2. Right, so this is the question that we have here. So what is it that they want us to do here? Let's read this question very quickly. They say a rectangular piece of sheet metal is 10 meters long and 5 meters wide. If the area doubles when the length and the width is increased by the same unit of the length, what are the new measurements? So basically they want to know what is the new length, what is the new width when the area doubles. So that's basically what do they ask for. But we are also given another information that you need to pay attention. They said here when the length and the width is increased by the same unit. So it means that the length and the width, they're gonna increase by the same unit length. All right, let me just draw it here, guys. So the 10 meter, it's under the length, right? So how long from here to there? It's 10 meters, right? And then the width from here to there, it's actually 5 meters. They say the area doubles now. So the area, let's make it bigger this time. The area doubles, okay? The area doubles. Basically, this is what is happening. The area doubles, right? There we go. So if this one has an area of 50 meters squared, then this one is supposed to have an area of 100, because 50 multiplied by 2, this is going to give us 100 meters cubed, because the area double. That's what they said here. Where is it? Let me highlight it very quickly. So the area doubles here, you guys see. So the area doubles, right? But then they said again, if you continue here, they did mention that the width, the length and the width is increased by the same unit of length. So we can say that same unit of length, we can say it's x. We don't know what it is, so we are looking for it. We can say it's x plus 10, because it increased by that meters, right? It increased by the same length. And then the width, we can say it's x plus 5 meters. You guys see? So we can say that because they say it increased by the same length. I cannot stress enough about this because we need to understand this one. It was a bit tricky, but if you pay attention, it's basically how you do it. So all right, so let's try to solve this one. So we know the formula of an area. The formula of an area is equaling to length multiplied by the width in this case, right? Let's start here. What is our area? Our area is 100 when it's double, guys, right? And then what is our length? Our length is x plus 10, right? What is our width? Our width is x plus 5. There we go. So from here we have to do the foil here. So we have 100, right? x multiplied by x, we have x squared, and then we can say x multiplied by 5 with plus 5x, x multiplied by 10 with plus 10x, and 10 multiplied by 5 we have 15. Right, we have 15. So from here we continue, we write x squared and plus, these are like terms, so what is 5 plus 10 is going to be 15x plus 5. Very simple. Then what we do, we take this 100 to the other side, we left with 0. This is going to be x squared plus 15, and then we have plus 50 minus 100. Right, so this is going to be the final answer. Our final answer is going to be x squared, oh I forgot x here, x squared 15x, what is 50 minus 100, it's going to be minus 50. So from here we need to simplify this one here. Okay, so let's try to simplify. So in fact we need to solve for x here, which is the same value that we are looking for here. So in order for us to solve for this x, let me just create a space here. We need to use, by the way, we need to use the quadratic formula, factorize this. So we use the quadratic formula. So the quadratic formula, we all know it goes like this: x is equal to negative b plus or minus b squared minus 4ac divided by 2a. Right, so from here what do? We just substitute. Remember, this is from this equation here, the quadratic formula. We know that a is a coefficient of x squared, and then b is a coefficient of x, and c is the constant. Right, is the constant. So you look at this and see whether they correspond. So let's substitute here. What is our b here? When you look at our b, it's a coefficient of x, it's going to be 15, so it's going to be negative 15. There we go. Plus or minus. Right, so what is our b again? Unfortunately it's still 15, unfortunately. Right, minus 4. Then what is our a? Is a coefficient of x squared, which is 1. And then what is our c? It's a constant here, which is negative 15. Negative 15. Okay, there we go. Even though it doesn't look so good, but that's negative 15 divided by, what is our a again? The coefficient of x squared, it's 1. Now there's something that I need to explain here. You see this plus or minus, basically this means or. So when you put this on a calculator, this is how you're gonna put it. So I'm gonna try to put it in that manner. So this is positive, or when it's negative, right? So each and every one of these, they're gonna give us the answer. So the answer for this one is gonna give us 2,80 meters. Okay, guys, don't forget that whenever you write your answer, leave it into 3 decimal points, guys. So since we are dealing with a distance, we don't have a negative distance here, guys. Right, so we scrap this one here, we scrap the one with the negative answer. So this one here, it's invalid. So this one, it's not applicable, guys. Right, so you leave this one here, not applicable. So meaning we have to take this 2,808 and then we substitute it on our formulas. All right, let's get our length and our width when it's double. So let's continue. So we know that this is a formula for length. Let me just go this way. All right, yes, this is a formula for length, and this is the formula for width. So we know that length, let me just write it here, length is gonna be there we go. Remember, they want us to get those length after the area is double. So this is the length here, and then for the width is x plus 5. So these are the final answers, guys, the width and the length when the area is doubled. So I hope you guys managed to see this one. It was a bit long, but really it was not that difficult. All right, guys, so this was 1.2. We are done with 1.2. If it so happened that you understood 1.2, don't forget to like the video, subscribe to the channel if you haven't subscribed, and also share this video to your friend. Now let's go and do the next question. Right, guys, so let's do question 1.3. So here's question 1.3. Now this question here, they just want you to make x subject of the formula. So here's the formula that they want you guys to solve here, or to manipulate. So I'm gonna copy this question and then I'm gonna put it aside so that we can able to solve this question, so that we can have space. Right, guys, so I already copied this formula. So what they want here, guys, they want us to make x subject to the formula. So how are you gonna do this one, guys? So the first thing that you must do here is to try to get rid of a fraction. As you can see, we have t is equaling to e to the power of 2x plus 1 divided by e to the power of 2x minus 1. So get rid of this fraction. So what you can do is cross multiplication. So you can say t, let me just do it very quickly. You can say t multiplied by underneath the denominator on the right hand side. So you cross multiply here, it's going to be e to the power of 2x minus 1. You have to know that t is divided by 1, so you also do the cross multiplication, which is going to be the same as the numerator on the right hand side, plus 1. So it's going to be e to the power of 2x plus 1. So this is actually how you do it. From there you get rid of the brackets. So let's get rid of the brackets. So the first term is going to be t multiplied by e to the power of 2x, and then t multiplied by 1 is going to be t, and this one here, there's nothing we can do at the moment. Just write it as it is on the right hand side. So from here, what you can do is you take this t, you transpose it to the right hand side, and you're going to take this e to the power of 2x, you transpose it to the left hand side. So let's do it. So let's start with this t. So we're going to have t, right, and then we have e to the power of 2x, and then we transpose this e to the power of 2x to the left hand side. So it's going to change the sign. It's going to be negative e to the power of 2x, then is equal to, so we also transpose this t to the right hand side. It's going to be 1, or it's going to be positive t, in fact, since it was negative, plus 1. So this is basically how it looks like. Then on your left hand side, as you can see, you have two terms here, and they both have e to the power of 2x. So you're going to take out the common factor. Let's take out our common factor, which is e to the power of 2x. So the first term here is going to be left with t minus 1, because the second term is going to be left with 1. And then we have t plus 1 on our right hand side. Right, so from here, what do? We divide by this t minus 1. So we're going to be left with e to the power of 2x, and then when we divide by t minus 1 on our right hand side, we're going to be left with t minus 1, because we divided by t minus 1 both sides, and then this they're gonna give you 1. All right, so this is what we have. So from here, guys, it's time for us to introduce the natural log. The best way here, just introduce the natural log. So when you introduce the natural log, you have to introduce it for both sides. There is a rule, let me just write it here very quickly, that goes like this. When you have natural log, let's say x to the power of 2 is the same as 2 natural log x. This exponent, it comes to the front. Do not forget that. So we're going to use this rule here on our left hand side. So we're going to take this 2x to the front. So it's going to be 2x, right, is equaling to 2x multiplied by natural log e, right? And then on this right hand side, we just leave it as it is. We don't do anything at the moment. So natural log t plus 1 and t minus 1. Right, I hope you guys can see what's happening here. Now there's another thing that you need to know. Natural log e is the same as 1. So here we can just say this is 1. So if we rewrite this, it's going to be x, then we continue, leave it the right hand side, we leave it as it is, because we cannot do anything at the moment, right? I know this takes longer, but step by step, so that everyone can understand. So from here, what do? We divide by 2 both sides. Remember, we're looking for x. We divide by 2 both sides. So when you divide by 2, here we're going to be left with x, right? And then we're going to have you can write it like this if you want to, 1 over 2 multiplied by natural log, and then we say t plus 1 and then t minus 1. All right, so this, you can leave it like this. I think the answer is correct like that, but you can still continue using the rule that I showed you here, guys. You see this rule? You can reverse. You can take it from here going this way. We have half, so if you take half to the other side, so we're gonna have something like this: natural log, and then we have t plus 1 over t minus 1 to the power of half, right? To the power of half. So this here, let me just put it here. This here, you can write it as x is equaling to natural log. What is power of half? If we say x to the power of half is the same as square root x. So we can do the same thing. We say square root, we leave it in a sub form. It's gonna be t plus 1 divided by t minus 1. So this here, guys, is our final answer, but I think you can also leave it here. I don't think they will have a problem with you guys. So that's basically how you do this one. I hope you managed to understand this one. If it so happen that you didn't understand anyway, you can pause this video, go back, and let's see if you can detect where you'll get lost. But if you manage to understand this one, don't forget to subscribe and share this video to your friends. All right, guys, let's do the last question of question 1, and then we are finished with question 1. Right, so this is the last question for question 1, which is question 4.1. So here they just want you to solve for x. I don't think this is difficult, but just in case you find it difficult, let's solve this one. Let's try to be quick on this one. Right, so I'm gonna copy this question here, and then we're gonna solve it on the side. All right, so let me copy this question and let's solve it. Right, guys, so let's do this one. 4.1.4, I mean, this blue thing here basically means the question is challenging, but I don't find this one to be challenging. All you need to know is that you need to use a calculator. But anyway, let's just do this one. So as you can see, you have 12 to the power of x plus 1 is equaling to 36. So we are solving for x here. So first thing first, you need to understand that this 12 to the power of x plus 1, you can actually use the exponent rules in order for you to solve this one. There are many ways of solving this one. I'd rather go with this way, okay? So you can use the exponent rule. You know that, let me just explain the rule that I'm talking about. If you have a to the power of n plus m, this is the same as a, right, and multiplied by a to the power of m, right? So you can separate this like that. It means the base they are multiplying, the exponent are adding. So let me rewrite it here. I can say 12, right, to the power of x multiplied by 12 to the power of 1. Even if you don't write it, it's fine, this one here, and then the answer is 36, or this is equaling to 36. So from here you can divide by 12. So let's divide by 12, dividing by 12, dividing by 12, even this side. So if I divide by 12 here, 12 and 12, they're gonna give us 1. So we left with 12 to the power of x, and here 36 divided by 12, we left with 3, right? So from here, guys, there's nothing we can do. We also need to just introduce natural log. So let's introduce our natural log here. So let's introduce it. So introduce natural log on this right hand side. You have 12 to the power of x, and then we have natural log here, then 3, right? Again, if you didn't watch the previous question, which was question 1.3, I did explain the rule here. There is another rule for natural log, which is similar to logs, by the way, where you have something like this, natural log, then we have x to the power of, let's say, a. We can say a is equaling to natural log x, where we take this exponent to the front. So that's what we did here. So we can do the very same thing here. We can say x, the natural log 12, and then this is equaling to natural log 3, right? So from here, what do? We divide by natural log 12. So this is gonna be x was that, and that it's 1. But this one here, you rather use your calculator, guys. So if you use your calculator, put this in your calculator, it's going to be 0.442. So that is your final answer. Like I said, this was not much of a challenge. You just needed to know your exponent and your logs at some point. All right, guys, so this is the rest of question 1. I hope you guys managed to understand it. I hope you managed to get the total marks for question 1. I'm hoping that you guys are sharing this information and also subscribing to the channel, because I'm going to do question 2 after here. All right, so this is question 2. As you can see, the question 2 has question 2.1, which we're gonna start with it, to question 2.4. So question 2.1, they want us to solve for x and y using complex numbers if this is given. So what you should pay attention to about this question 2, it consists of complex numbers and determinants. So I hope you are ready for that, because this is most of the things that we'll be dealing with on this question. So let's copy this question and let's paste it somewhere so that we can do it. All right, so this is our question 2.1. Now, in order for us to solve this question, we need to know certain things about determinants. So I'm going to show you a formula that we use to calculate determinant. First of all, determinants, they are given in a matrix format. So you will be given something like this: A1, B1, A2, B2, 2. Now we call this one here, since it has only 4 items, we call this one the second order, by the way. So in order for us to calculate the determinant, it should be in the second order. Now we have a column and we have a row. So the formula to calculate a determinant is very simple, guys. The determinant is equaling to, now let's do the multiplication that I'm talking about. You multiply A1 with B2. So it's gonna be A1 multiplied by B2, right? And then subtract. So the second term is gonna be the multiplication of A2 with B1. So let me show you. A2 multiplied by B1. I hope you guys know about this, because I haven't done any videos on determinant, so that's why I'm explaining this basic thing here. So when you calculate the determinant, this is how you're supposed to do it here. So this formula, this what is given to us here, we need to use this formula in order for us to get our y and x. So let's start. I'm just gonna do it here so that we can have enough space. So let's look on our left hand side. We have xj multiplied by -2. Guys, by the way, j represent imaginary number. If you still remember, complex numbers are, it's a mix of real numbers and imaginary numbers. So wherever you see a number with I or j, basically means it's a complex number. So let's use this formula to calculate. So it's gonna be x, let me just change the color here, guys, change the color. It's gonna be xj multiplied by -2. As you can see, it's A1 multiplied by B2. So let's do it. So on our left hand side, it's gonna be xj, right, multiplied by -2, right, and then minus. Don't forget, we are minusing. So when you minus, the second term here is gonna be A2 multiplied by B1. So what is our A2 here? It's gonna be our -3 multiplied by yj multiplied by yj, right? So that's how you do this one on our left hand side. So let me just erase this very quickly, right? So equaling to, so we are done on our left hand side. So we say equaling to. Now we go to the right hand side. So what you should pay attention to, our right hand side here, we have x minus y. This on its own, it's actually A1, this one here. Let me just write it there. So let's continue. So we say A1 multiplied by B2. A1 multiplied by B2. So our B2 here is going to be 2. So this one here, in order for you to do it, it's going to be like this. A1, which is x minus y, multiplied by B2, which is 2. Even if you put it in a bracket like that, and then you close everything here, and then don't forget, after this one you subtract. So let's subtract here. So when you subtract, it's gonna be A2 B1 or A2 multiplied by B1. So B1 multiplied by A2 or A2 multiplied by B1. So it's gonna be J multiplied by -4. So in this following bracket, it's gonna be J multiplied by -4. Right, I hope you guys can see this. Really, it's not that difficult. You just have to pay attention when you do this. Now it's time for us to remove the brackets and simplify this. So we know that x multiplied by j is multiplied by xj multiplied by -2 is going to be -2xj, right? And then this one, negative and negative, this is going to give us positive. So 3 multiplied by yj is going to be 3yj, right, equaling to. Now let's look at this one here. So this one, in order for us, we have to just multiply by 2 throughout. So we're going to have 2x minus 2y. Right, so this one we have to multiply negative and negative, meaning this is going to give us positive. So we say j multiplied by 4, this is going to be 4j. Right, so when it's like this, now this is where we want it, guys. When you're solving for x and y with complex numbers, you need to make sure that the equation that is given to you, it's linear. There are no fractions here. As you can see, there are no fractions here. Now the next step, you have to do the grouping. So the grouping, it goes like this. You will group the imaginary numbers on their own and real numbers on their own. So let's start with imaginary numbers. So I'm gonna write imagine here just to group them. Right, so imaginary numbers, we look on your left hand side, which is this one here, and then any number that has j, you write it here under the group of imaginary numbers. So we have negative 2x plus 3y. There's no need for you to write the j here, because this word imagine, it implies that these are imaginary numbers. So we don't have any other imaginary numbers here, so we go to the right hand side. When you look at the right hand side, the only imaginary number that we have here is 4j. So you equate it only to the imaginary number on the right hand side, so which is 4j. Right, so don't write j as well, just write 4. Right, so this becomes equation number 1. Right, now that we are done with imaginary numbers, it's time for us to group real numbers. So let's group real numbers. Right, just write real, guys, to indicate that you are grouping real numbers. Okay, so when you look on your left hand side, there is no real number here, so meaning we put 0. There was no real number here. Each and every number which is on our left hand side is actually associated with j, so there's no real number, 0. Now we go to the right hand side. When you look at the right hand side, we do have real numbers. We have 2x and we have minus 2y. So you write those, 2x minus 2y. So that will be equation number 2. So you have two equations now, meaning you can able to solve for x and y using simultaneous equation or elimination. I prefer to use simultaneous equation, guys, because it's less simple and we use it a lot with mathematics and science. So the next step is to manipulate equation number 2 and make x or y subject to the formula. So I'll make y subject to the formula. If I take y to the other side, I transpose y to the other side, this becomes 2y is equaling to 2x. Then we just divide by 2 both sides. So when we divide by 2, this becomes y is equaling to x. So we can say this is equation number 3. Right, so with this done, we can start substituting. You can say substitute equation 3 into equation 1. All right, I have to clarify something here, guys. Do not substitute equation 3 into equation 2. The reason why is because this equation 3 is derived from equation 2. Right, so wherever there is x, we must put y, or whatever there is y, we must put x. It's up to you. So I rather start by getting y first. So wherever there is y, wherever there is x, I must put y. So we have negative 2x. Instead of writing negative 2x, I'm just going to write negative 2y. Remember, wherever there is x, I put y, plus 3y. This is equaling to 4. Now when you look at this, guys, let me create more space a bit here. When you look at this here, you can see these are like terms. We have negative 2y plus 3y. You're gonna have y on your left hand side. So on your right hand side we have 4. Therefore y is equaling to 4. But when you look at equation 3, it says x is equaling to y, or y is equaling to x. So you can say, therefore x is also equaling to y. I hope you guys understand this. It's really not that difficult. It needed you only to know how to do determinants and also how to group the real numbers and imaginary numbers. Alright guys, if you so happen that you didn't understand, you can ask a question in the comment section, and also you can rewatch at the point where you feel like you were lost. And don't forget to share these videos to your friend, and also subscribe to the channel. Now that we are done with question 2.1, how about we go and do question 2.2. Alright guys, so we have 2.2. Let me highlight it here. 2.2, it actually consists of two questions. So 2.2, we are given z1 and z2. So z1 is 4 with an angle of 30, and then z2 is 2 with an angle of 60. This here is complex numbers. Now they are in a form of a polar form. So let's solve this problem and let's see if it's gonna be that simple. So I will copy it and then I'll paste it on this side. So let me copy the problem. Right, so this is 2.2. So let's look at 2.2.1. They want you to get or determine when z is multiplied by z2. Remember, z1 is this here and z2 is that there. So like I said, this is a polar form. So all you need to understand is that in a polar form, this 4 here and this 2, they are actually real numbers. We call them modulus. And then this 30 degrees and this 60 degrees are angles. We call them argument. So when you multiply these two complex numbers, what's going to happen is the real numbers, they actually multiply, and the arguments, they actually add. So let me show you what do I mean by that. I'm gonna do it here, 2.2.1, right, so that you don't get confused. So you're gonna say 4 multiply 4 to angle 30 multiplied by 2 angle 60. Basically this is what they are asking them. And then from there, the moduli or the real numbers, they actually multiply. So this here is going to be 4 multiplied by 2, but then the arguments or the angles, they actually going to add. So it's going to be 30 plus 60. So your final answer here is going to be 8. Then the angle is going to be 90 degrees. So they never specified, so rather leave it like this as a polar form, right? So this was very simple, guys. So let's look at 2.2.2. So when you look at 2.2.2, they are actually dividing now. This is z1 divided by z2. Another thing that you need to know about this is that the real numbers or the moduli, they will actually divide, while the argument or the angle, they will actually subtract. So let me show you how. So z1, do not forget, z1 is the one with the 4, so it's going to be 4, and then angle it's 30, and then you divide there by z2. So z2 here, which is going to be 2, and then the angle here is 60. Now when you continue here, the numbers, they're actually gonna divide. So 4 divided by 2, but then the argument or the angle, they're gonna subtract. What you should know, the angle that is on the numerator, which is 30, is gonna be positive, where the angle that is underneath or on the denominator is gonna subtract, right? This is what you need to know about complex numbers in a polar form. So when it's like this, now what is 4 divided by 2? This is gonna be 2. And then when you look at the argument there, it's going to be 30 minus 60. So our answer is going to be negative 60 degrees. Let's not forget the degrees is here. I forgot to write them. So unless they say otherwise, guys, you leave your answer like this. Sometimes they do say leave your answer on with a positive argument, meaning the angle must be positive here. Then that's where you're gonna do that. If they don't specify, just leave it like this. The only thing that is specified here, they say to you leave your answer in a polar form. This is polar form, so basically this is your final answer. Guys, this is how you do this one. I hope it was not that difficult. If it so happened that you didn't understand anything here or something, leave a comment, and also you can go back to the point where you feel like you were lost and rewatch that point. Alright guys, if you haven't subscribed, don't forget to subscribe and also share this video to your friends. Alright, it's time for us to do the following question, which is question 2.3. Alright guys, let's look at 2.3. But before we look at it, I need you guys to pay attention to the error that is here, guys. There is a printing error here, so be very careful. But 2.3, it's actually this question here. So they just want you to simplify this question that I'm highlighting here. Yes, they just want you to simplify it. As you can see, even the marks, they're not that much, guys. It's only 2 marks, right? This portion underneath, it is an error that happened while they were printing, I assume, right? So let me copy this and let us simplify this 2.3. Alright guys, as you can see, 2.3, it's complex numbers. Now before we start with this, I need to inform you about this J. Remember, J represents imaginary number. If you haven't watched the first question here on question 2, I did explain what is this J, but then how did it came about. So I will write on the corner here exactly what is J and how is it imaginary number. So this J here, as you can see, is the same as root -1. If you put this on your calculator, you will get an error because this number doesn't exist, it's imaginary. But then you can say this J squared is the same as -1, right? Some of you may ask, how did this came about? Look, if you decide to square this, let me just do it this side. If you decide to square this J, you must also square this root -1. So root -1, when you square it like that, remember the square root and the square, they will give you 1. So you're gonna left with -1. So basically this is what this is coming from, or this is where this is coming from, right? I hope you can see there, though the space is so little. Okay, so J squared is the same as the -1. So whenever you simplify this, guys, what you should do, wherever you see J, especially a J with the exponent that is greater than 2, you just substitute with 2. Then you have to manipulate it using exponents law to be exactly like you are given. So here's what I am talking about. Let me show you how. So you have 2 here, and then you have J to the power of 16. Instead of writing J to the power of 16, you first write J to the power of 2. Now how are you gonna find a number, or what is a number that when you multiply by 2 it gives you 16? It's actually 8. But some of you might say, how do you come to 8? So it's very simple. You just say 2 divided by 16, and then you're gonna get 8. Basically that's what you do, and in that 8 you write it here, right? Especially when it's an even number on the exponent, right? So when it's an odd number, it's where you have to use the exponent, or you have to remember your exponent laws. Remember, wherever there is a J above the power of 2, you first write it like this. So how can we manipulate this to give us J to the power of 3? So if you still remember the exponent's law, we know that if the base are the same and they are multiplying the exponent, they will do what? The exponent, they will add there. Do you guys see? So if we have J to the power of 2, we can say multiply by j, because let me show you here, guys. If I say j to the power of 2 multiplied by j, since the bases are the same, what happened to the exponents? They're gonna add, so it's gonna be 2, this one, plus this one here. So the final answer is gonna be j to the power of 3. So whenever it's an odd number, chances are you have to do it this way. You have to take that number or that remainder and then you put it on the side, then you're left with the even numbers here as an exponent, right? So I hope you understand how I did this one here. So from there we know that j squared is the same as -1. So we just substitute here -1 to the power of 8 minus 9. But then this one here is just going to be -1 multiplied by j. You guys see? So from here we can say 2 multiplied by, if you put this on your calculator you will have 1. Guys, make sure whenever you put this on the calculator you include the bracket. You don't want to put this without bracket, you'll get a wrong answer. So put it as you see it, like this. So 1 multiplied by 2 is 2, so you leave it like that. But when you go to the second term, we say -9 multiplied by -1, this becomes +9 multiplied by j. So this is actually your final answer. By the way, this is a rectangular form. So when they say simplify, basically they wanted you to leave it like this. Unless they specify to rectangular, to polar form, then you have to use the formulas to change this to polar form. So they never specify, so you leave it like this. Guys, I hope you understand. This was not difficult, it's just that you need to know the basics about complex numbers and the basics about the exponents law. Right guys, so if you so happen that you didn't understand, you can just restart from the beginning of this question and then make sure you understand this. I don't think there is anyone who wouldn't understand this, but if you don't, you can also leave a comment on the comment section and I'll try to help you as much as I can. But if you do, you don't forget to like the video and also subscribe if you haven't subscribed. Okay, let's now go to question 2.4. Right guys, now it's time for us to do 2.4. Now 2.4 guys, before you do it, please pay attention to this printing error that we see here. Okay, this question that you see here guys, it's actually under 2.4. Now if just in case you didn't see this is an error guys, so I'm just highlighting actually what's happening here. As you can see, this question here, it's actually determinant and this is a third order. So I'm gonna copy this question and paste it where we're gonna able to solve it. So for now, let me just copy it and paste it. Right guys, so I just managed to copy this question. Now it's time for us to start solving this question here. As you can see, this question here, it's a third order. How do you see it? It actually has 3 rows and 3 columns. Basically that's how you see it. So in order for you to solve this question, you need to know certain things guys. So one of the things that you need to know is how to calculate for determinant. So let me show you how to calculate for determinant. So the formula for determinant, first of all, you need to have the matrix in 2 order or the second order guys. Okay, in order for you to calculate the determinant, you need to have the matrix in second order. So it's supposed to look like this in second order, right? Let's say you have A1 on this row and B1. Just be quick, B1, and then on this column this A is gonna be 2, and then on this column this B is gonna be 2. Now when you look at this column here, we have A1 and A2. When you look at this column here, you also have B1 and B2. Now the rows, they have A1 and B1, and then the second row it has A2 and B2. So as you can see, we call this one the second order because it has 2 rows and 2 columns, right? So when you calculate for the determinant, there's a formula for it. So the formula, it goes like this: determinant is equal to the product of A1 and B2. So when you say A1 like this, A1 multiplied by B2, that is the first term, and then you subtract these 2 terms with the second term, which is B1 multiplied by A2. So B1 multiplied by A2. So the product of B1 multiplied by A2 subtract the product of A1 multiplied by B2. I hope this makes sense, right? So basically that's how you calculate the determinant here. Now another thing that you need to know, guys, is what we call cofactors, right? Guys, this question, it might take longer, so you need to make sure that you brace yourself. So cofactor signs are for the third order, guys, right? Let me show you the cofactor signs. So the first is going to be positive, negative, then positive, and then it's going to be negative, positive, then negative, then positive, then negative, then positive. So like I said, this is for the third order because you have 1, 2, 3 columns, and you're gonna have 1, 2, 3 rows. So we use this when we calculate the minus, or when we use the minor. I'm gonna show you as we calculate how exactly the minors are used on this problem here, right? So if you know this, how to calculate the determinant and the cofactor and the minor, I'm gonna show you earlier or later on, then you can able to calculate this. So one of the things that you should pay attention to, let me just change the color here. One of the things that you should pay attention to, look at our matrix or our equation here, our problem. In fact, this problem here, we are given 3 formulas, right? We have the first one where we have 1 over x plus 2 over y plus 1 over z is equal to half. So this question here, when you look at it, there was no specific question on that question on the question paper. So when it's not specified, the best way is to find the unknown, the x, y, and the z. So how are we gonna do that? First of all, you need to rewrite this matrix here. Let's rewrite it next to the question. Now when you rewrite this here with the third order, you need to make sure, guys, that you only take the coefficient of the variables here. So as you can see, the first one here, the coefficient that you must take here, it's 1. This one that follows, it's 4, and the other one is gonna be 3, right? So on the first column we will have 1, 4, and 3. I know that if you look at our x, it's actually a fraction. Don't pay attention to that, just take the numerator when it's like this. Now let's go to the second column. So you're gonna take the coefficient, which is 2, and also this is gonna be 2. Now look at the last number here, which is gonna be negative 4. So you take it with its sign. If it's negative, it's gonna be negative 4. So this column here, as you can see, is 2, 2, negative 4. So the last column for z is gonna be 1, negative 3. Look at this, this is negative, guys, right? And then positive 4, right? Again, before we start, I just want to remind you guys, pay attention to the order of the equations that you see here. These equations, sometimes we can misplace, or we can swap the variables here. I can decide to put y here and then put x on the other one. When it's like that, you need to rearrange so that all the first term is x, the second term is y, and the third term is z. So be careful of that. Since this one there's no such a thing, we are fine. Alright, so this is your matrices. Now we have to calculate the determinant first before we even calculate for y, x, and z. So how do we calculate the determinant on the third order? you need to use the minus. So how do you use the minus? First of all, when you select the minus, you must select one row or one column. So the best way of doing this, guys, is to select the first column or the first row, but you can select any, but just know that if you select the first column and the first row, life is easier. I like to think that way. So this here, they will be our minus, guys. Okay, I'm gonna highlight them. Right, so as you can see, these ones here are our minus. Let me just put them here. So I decided to take the first column and make the numbers within the first column minus, right? So how are we gonna use this minus to calculate our determinant on the third order? So it's very simple, guys. It's very simple. So let me show you. So determinant, right? Let me first do this. When the minor, let me start here. When the minor is 1, this one here, minor is 1, this one here, then our determinant, let me just do it here. Try to create more space, guys. Okay, alright, so it's gonna be like this, meaning each and every row and every column that one it's part of, we just gonna cancel it, right? So we're gonna cancel. So since 1 is our minor, we're gonna cancel this row here, right? And we're gonna cancel this column, right? We're gonna cancel this column, meaning now we're gonna be having only 2, -3, -4 and 4, which looks like the second order. So we can able to calculate the determinant. Now when you write here, you first look at the minor. You know that the minor that we are using it's 1, and then we look at the cofactor sign. So the cofactor sign here is positive, so you multiply by the minor and the sign of that minor. So it's gonna be 1, since 1 is positive because of the cofactor sign here. Look at the minor, it's here on the first one, and on the first one here it's positive. I hope you guys can see this, right? And then from there you multiply. So let's look at how do we multiply here. We say a1 multiplied by b2. In this case, now when you look at this, a1 is this and b2 is that, so it's gonna be 2 multiplied by 4. All right, so you will need lot of space here. Then the next step, we subtract here. We are using this formula now. And then after that, the next product is going to be b1 multiplied by a2. In this case, our b1 is -3 and our a2 is going to be -4. All right, let's do this. So it's going to be -3 multiplied by -4. Right, I hope you guys understand, right? So we are done with when the minor is 1. Now when the minor is 4, so we have to move these lines. So since I'm using a computer, guys, it's easy for me to move these lines. Okay, I have to move this line here. In fact, when we use this line, so wherever the row 4 belongs to, we cancel it, and wherever the column 4 belongs to, we also cancel. So we are left with 2, 1, -4 and 4. So the next step, we just write minor it's 4. So this 4 here, guys, you guys see, right? So let's look at the sign for this minor. This 4, as you can see, it's on the second row but the first column. So second row but the first column, the sign it's negative, so you write negative here multiplied by the minor, which is our 4. Then from here you start, guys, right? You put this on a bracket. Now look at this. Now we have the second order here. We have 2, 1, we have 2, 1, -4 and 4. So we calculate the determinant here. So what is our determinant here? It's a1 multiplied by b2. So our a1 here is 2 multiplied by 4, 2 multiplied by this 4 here, right? Really, it's not that difficult once you get it, guys. It's not that difficult. Then minus. Now let's look at our formula. The second product is b1, or b1, which is 1 multiplied by negative 4, b1 multiplied by a2. So it's going to be 1 multiplied by negative 4, right? So this type of problems, guys, they need you to have time, space, so that you can able to write everything here. Are we still fine? I hope we are still fine, guys. Right, so let's go to the next one. We are done with this one. Now all you have to do is move this line and we come in. Do not move this line anywhere else, because we are using, remember I circled here to show that these are the ones that we're going to use. Okay, so our minor this time is going to be 3. As you can see, we're going to cancel the row where 3 is, and also we're going to cancel the column where 3 is. So you write here minor, okay, it's 3. Now when you look at the cofactor sign for minor, where on the first column and the last row, you can see the sign is positive, so you write plus 3. You write the minor and the sign, right? And then from here, now we are left with 2, 1, 2, negative 3. This is the second order. I hope, guys, this makes sense. Really, I need you guys to pay attention here, because if you don't get this one, you might waste your time, guys. Right, so let's do it. Okay, so it's time for us to multiply a1 with b1. So what is our a1 here? Our a1 is 2 multiplied by b2, not b1, by the way. a1 multiplied by b2, which is gonna be negative 3. All right, and then we say minus. Remember this formula, you minus them, then b1 multiplied by a2, which is 1 multiplied by 2. All right, 1 multiplied by 2. All right, so this is how you actually calculate the determinant. So try not to put everything in a calculator, you might make a mistake. So the best way is to get the answer for minor when it's 1, which is going to give us negative 4, and then when the minor is 4, it's going to give us negative 48. The minor is 3, it's going to give us negative 24, and then when you add them together, they give us negative 76. So this, guys, is our determinant. All right, now that we have finished getting our determinant, it's time for us now to calculate the determinant for x, y, and z. So I'm going to start with the determinant for x. All right, so in order for us to calculate the determinant of x, which is dx, and also for determinant of y and z, we need to move these answers here. Do you see these answers here? Right, so these answers here, we need to rewrite our matrix and then move these answers here to the determinant that you're looking for. So if you are calculating for determinant for x, these ones, you're gonna take them to the front. So when you rewrite your matrix here, let me just do it. Instead of writing the original 1, 4, and 3, you're gonna write 1 over 2, since this is for the first answer. Then you're gonna write 3, on the first column you're gonna write 2 over 3, and then you're gonna write 1 over 3, because these are the answers here. So since we're looking for dx, they must come to the first column, because the first column, it has x, 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 x. Right, then you continue, you write the second column as it is with their values there. So this is gonna be like that. Nothing changes here, because we are not looking for any other than the x. And then from here you continue with the same step, right? Like I said, never change your minor. You select your minor. You can change if you want to. You can decide to use the first row as your minus, or the row in the middle, the column in the middle as your minus. I would advise you to do that. Rather use the first one, right? The first column, right? If you started with the first column, rather use it through and through. If the minor is 1/2, it means now we're gonna cancel the row where the minor is and the column when the minor is. So I'm gonna show you by taking these lines and cancel the first row and cancel the column. Do you guys see? Basically, that's how you do it. Then you repeat the very same steps that we did here. Alright, so let's calculate our dx. So what is the minor? We know that the minor is half, so we're gonna cancel the row of this minor and the column. Now we're gonna be left with this 2, -4, -3, and 4. So we're gonna use this to do the calculations. Alright, so let's start. Let's look at the cofactor sign here. For this minor here, it's gonna be positive, so it's gonna be positive 1/2. Remember, this is half the minor. Then from here we put this on a bracket, right? Let's put this on a outer bracket, and then from here we're gonna use the second order to calculate the determinant. So we know that it's a1 multiplied by b2. So in this case, a1 is 2 multiplied by 4. There we go, 2 multiplied by 4, and then minus, and then gonna be b1 multiplied by a2. So in this case, b1 is gonna be -3 multiplied by -4. Right, I hope you guys can follow through. So I forgot to write minor here, guys. It's not necessary for you to write minor. I just write this minor thing so that you guys can able to follow through. When the minor is 1/2, this is how you do this one, right? So let's look at when the minor now it's 2/3. So remember, we have to move this line here to cancel that row. Already, as for column, we are fine. We don't move anything, guys. As for column, we don't move everything because it's already on the first column, right? So when the minor now it's 2/3, which is on the first column and the second row, we have the negative sign. But let me just write here minor, right? It's 2/3. So what is the sign for the minor here? 2/3. It's gonna be negative here, so you write negative. There we go. Then you multiply by 2/3, which is our minor. We write our bracket here, the outer bracket, and then we are left with 2, 1, -4, and 4. And then when you use this formula, it's a1 multiplied by b2. In this case, a1 is 2 and then b2 is 4. So it's gonna be 2 multiplied by 4, right? Minus. Now b1 multiplied by a2. In this case, b1 is 1, a2 is gonna be -4, right? So it's gonna be 1 multiplied by -4, right? -4. There we go. Right, now we are done when the minor is 2/3. Now it's time for us to move to the last minor, right? So let's move it. So when our minor is 1/3, as you can see this one here, we look at our sign here. So let me just write here minor, it's 1/3, right? So what is our sign here? Remember, this is the first column but the last row, so the sign is gonna be negative, positive, I mean. So even here, so we're gonna write plus 1/3. 3. Don't forget you write the minor. Just in case you forgot, guys, the minor you choose whether the minor here you choose. This is your own choice, guys. These minors that you're using, this 1/2, 2/3, and 1/3. We just chose it. It's your own choice. You can choose the first row, you can choose the second row, the third row, however, it's up to you. So I decided to choose the first column. It's easier that way, right? So when it's like this, remember we cancel the row at which 1/3 is a minor, and then we also cancel the first column. So we're gonna be left with 2, 1, 2, and -3. So we calculate the determinant here. It's gonna be a1 multiplied by b2, or a1, which is 2, which is gonna be multiplied by -3. So let's do it. Put that in the bracket. It's gonna be 2 multiplied by -3 minus. Guys, I hope I am audible, because I'm trying to be as careful as I can be, right? And then minus b1 multiplied by a2. b1 multiplied by a2. In this case, our b1 is 1, our a2 is 2. So it's gonna be 1 multiplied by 2, right? And then you put this in the bracket. Now if you put this on a calculator, remember you must try to write it, guys, in differently. Okay, let's get the answer for the first minor, which is going to be -2. The answer for the second minor, which is 2/3, is going to be -8, and then the last one is -8/3. So dx is actually equaling to negative, just write it, 38/3. All right, so this is our dx. So how do you actually calculate x? Now the formula to calculate the x value is very, very simple, straightforward. It's going to be x is equaling to, since our x, actually when you look at our matrix here, our x is 1/x. You guys see, even on the second row, it's actually 1/x multiplied by 4, 1/x multiplied by 3. So the formula is going to be d, the determinant that you calculated here, divided by the determinant of x, right? The determinant of x. So what is the determinant that we calculated there? It's going to be -76 divided by the determinant of x, which is -38 divided by 3. So x is equaling to 6. If you put that in the calculator, x is going to be equaling to 6. So guys, this is how you do it, guys. This is how you get your x. So let me erase this so that we can get dy. All right, guys, so let's get dy. So before we get dy, remember, now it's time for us to move this answer to the column where our y is. So our y is at column number 2. Since we are looking for dy, we need to move these answers to y. So let's rewrite it. Then this means that for x, we are taking back these numbers here on the first column. So it's going to be 1, 4, then 3. Then now, since we are looking for the determinant for y, we want to take the answers here, which is going to be 1/2, and then which is going to be 2/3, and which is going to be 1/3. And then since we are not looking for for determinant for z, we keep this one for z. So it's going to be 1, -3, and 4. Right, and then here we're just going to write dy. Now we are looking for determinant for y, guys. Determinant for y. Right, let's continue. Right, so it's time for us to select the minus. Like I said, guys, select the first column. Don't change, remain there. Do not change, guys. Just select this, the first column. Make your life easier, right? Just make your life easier, right? So let's continue. Now when you look at the first column, what is our minor here? Our minor here is gonna be 1, right? So we're gonna erase this 1 here, and then we also need to erase the column where 1 is part of. Basically that's how we do it, right? So from here, this means that we're gonna focus on this to calculate the determinant, right? So let's continue. Now let's look at the cofactor sign. Now if our minor is this 1 here, then our cofactor sign is going to be positive. If you look at this, so it's going to be positive 1, right? And then we put it on the bracket. Now let's calculate our determinant. Remember, determinant, it's a1 multiplied by b2. In this case, it's going to be 2 over 3 multiplied by 4. So let's do it. 2 over 3 multiplied by 4. By now I think you should be able to see this minus. Now it's going to be b1 multiplied by a2, which is negative 3 multiplied by 1 over 3, right? Negative 3 multiplied by 1 over 3. Again, I'm just going to write here to remind you guys, minor is 1, right? That's why we have this, right? So we move to another. Now when we move to another, which is going to be 4, let me just try to move this. It's going to be 4. We are going to scratch the minor, the row at which this minor is part of. Already we scratched the column, so this is going to be scratching the second row. So what is the cofactor sign for this minor here? As you can see, this is the first column, but the second row, which is going to be negative. So we put negative here, right? And the minor is 4, right? So what is our minor? That minor is going to be 4. There is our bracket. There we go. And then we have the inner bracket. Now since we are having this, now we know that a1 is half, b1 is 1, a2 is 1 over 3, b2 b2 is 4. So let's start. It's time for us to calculate the determinant here. So it's gonna be a1 multiplied by b2, which is a1 multiplied by b2, which is half multiplied by 4, half multiplied by 4, right? Minus, don't forget we subtract, and then it's gonna be b1 multiplied by a2, which is 1 over 1 multiplied by 1 over 3. All right, let's do it. 1 multiplied by 1 over 3. So when the minor is 4, this is how we do our determinant. I hope you guys can see what is happening there. Now the last but not least, it's time for us to go to the last minor. So the last minor here is actually 3. So you're gonna take this line and you're gonna scratch the row there, so that you're gonna be left with only this part here. Now look at this minor here, which is the third one here. What is the sign of this minor? Because this minor is at first column but last row, so the cofactor sign is going to be positive, so we see plus here. But what is our minor? Our minor here is going to be 3. Right, I know you guys are in a rush, but let's try to understand what we are doing here. So the formula is going to be a1 multiplied by b2. In this case now, our a1 is going to be half, and then b2 is going to be negative 3. So it's going to be 1 over 2 multiplied by negative 3 minus, right? Now let's look at our second term, which is going to be b1 multiplied by a2, b1 multiplied by a2. In this case, it's going to be 1 multiplied by 1, 2 over 3. 1 multiplied by 2 over 3. Right? It's not, that 2 is not really visible. Try to make it visible. Then you close the bracket. Right. And then from here, guys, you put this on your calculator. Be very, very careful, guys, when you put this on your calculators, because it's easy to make mistakes here. So dy in this case now is going to be what? It's going to be, let's start with the minor. Oh, by the way, here the minor is, I almost forgot, guys, the minor is 3, right? So we start by getting the answer for the first minor. What is our answer for the first minor? It's going to be 11/3, right? The other one is going to be the second minor, which is 4. It's going to be -20/3. And then the last one is going to be -13/2. Right. So when you put this on a calculator, dy is going to give you -19/2. Right, 19/2. But then when you're looking for y, it's going to be equaling to the determinant that we calculated earlier on, right? Divide by dy, right? So what is our determinant? -76 divided by -19, just 19/2. So the answer here you're going to get is going to be 8. So y is equaling to 8. So this is how you do this one as well. Now it's time for us to do the last one. So I will have to erase this. Right, let's do the dz determinant. Remember, we need to find the determinant of z. Now this time around we're gonna move these ones to the third column, which is for z. So let's rewrite this and then let's move our answers there. Right, so the first column we're gonna write it as it is this time around, and then the second column we're also gonna write it as it is this time around. But now the third column for z is gonna be 1/2, it's gonna be 2/3, and it's gonna be 1/3. Right, so we are looking for dz. Right, so here guys, what you need to do is to select the minus. So like I said, rather select the first column, guys. Rather select the first column, but it's optional. You can select any column, any row. I prefer the first column. Then once we select the first column, meaning the first one here is gonna be our minor, which is gonna be 1, right? Our minor is gonna be 1, and if our minor is 1, we're gonna cross the row at which 1 is at and the column at which 1 is at. Basically, we just do what we were doing before. Alright, so let's do this. So our minor here is 1. Let me just write minor, which is 1, this one here. At what column and what row is this one? Is the first column and the first row. So the cofactor sign is going to be positive, so it's going to be 1. Then we're going to multiply by the determinant of this. So our determinant is going to be a1 multiplied by b1. In this case, it's going to be 2 multiplied by 1/3, because this is our a1, this is our b2, in fact, not b1. It's going to be 2 multiplied by 1/3. There we go. Minus. Then the second term is going to be b1 multiplied by a2. So what is our b1? Our b1 is going to be 2/3, and then our a2 is going to be -4. So 2/3 multiplied by -4. Right, so that is it for when the minor is 1. Now let's move to minor 4. Now you take this line here, you scratch a row where this minor is 4 and the column. So the column, you don't have to worry about it because we already chose the first column. Right, so let's look at this. What row and what column is 4 at? So it's our first column but the second row. So when you look at our cofactor sign, this is going to be negative, so it's going to be negative. So our minor here is going to be what? It's 4. So you're going to write negative 4. Then we start multiplying. So it's going to be 2 multiplied by 1 over 3 because it's a1 multiplied by b2. So it's going to be 2 multiplied by 1 over 3 when you look at this, right? And then minus. Now for this one is going to be b1 multiplied by a2. In this case it's going to be half multiplied by negative 4. So it's going to be half multiplied by negative 4, right? So we are done. When the minor is 4, it's time for us to move when the minor is 3. So we're going to take this and then we scratch the row at which 3 is at. So now as you can see, 3 it's at the first column and the last row, and then meaning we're going to scratch here. So when you look at the cofactor sign for that position, it's going to be positive, so it's going to be plus. But then what is our minor here? Let me just write it, minor. Guys, you don't need to write this. I'm writing this for explanation purposes. It's going to be 3, and then from here we have to multiply. So it's a1 multiplied by b2. In this case a1 is 2, and then b2 is going to be 2 over 3. So it's going to be 2 multiplied by 2 over 3, right? Doesn't look so good. Let's see, let us write our 3 nicely. 3. Okay, hopefully you can see this. Minus, right? Minus. Let's do the other one, which is going to be b1 multiplied by a2. So it's going to be half multiplied by 2. So we're going to say 0, 0 over 2, I mean, multiplied by 2. Okay, let me just create a bit of space here, a little bit of space, and then you put this on a bracket, right? So as you can see, this needs some some space and time, so you have to pay attention when you do this. So when you put this on your calculator, where you need to be very careful, guys, your d z is equaling to like I said, always try to write them one by one. For the first minor, which is 1, is going to be 10 over 3 minus, and the second minor is going to be 32 over 3, and then the last one is going to be 1. Now this dz going to give us negative 19 over 2, right? So when we calculate for z is going to be d over dz. Alright, let's do it. dz. Alright, so the answer is going to be what? What is our d? Our d is negative 76 over negative 19 over 2. So our z here is going to be 12. So this is how you get your z. So when we go back and double check, our x was equaling to 6, our y was equaling to 8, and then our z is equaling to 12. Now if you can take these variables and substitute them here on any of these formulas, you must be able to get the answers here. For example, if you say x in this case is 6, y in this case is 8, and then z in this case is 12. When you put this on a calculator, you will get this answer, which is 1 over 2. So that's how you check whether your answers you've done it right. Guys, this was very long. I hope you guys understood. If you didn't understand, you can go back to the question or to the spot where you didn't understand and replay them. You can also leave a comment, but this time you must leave a timestamp where you're not so sure, and ask a question if there is any question. And if you really like this video, it really helped you, don't forget to like, and also don't forget to subscribe to the channel. Now that we are done with question 2, all I can say is we're about to do question 3. Alright, so this is our question 3. As you can see, question 3 consists of 3.1, 3.2, 3.3 and 3.4. So these are the questions that are in this question. Now we're gonna start with question 3.1. As you can see, question 3.1, let me highlight here. They just want us to simplify this problem here. So I will copy this and then I'll paste it so that we can have enough space. As you can see, I've already copied the question here. So let's simplify this question. So first of all, we'll have to change the identities here and also the inverses. So let's start with the numerator. We know that 1 over cos squared is the same as sec squared then, so I use the inverses to change that, and then minus. So on the numerator we have tan squared. That tan squared, you can use the quotient identities and write sine squared theta over cos squared theta. Right. By the way, this solid line here represents division, so you can write it like this, and then we can say divide by 1 minus. Now look, when you look at this here, this is a 360 minus theta, meaning this is our fourth quadrant. On the fourth quadrant, cos is actually positive, so if you use the 180 rule, you can write this as cos squared theta. By the way, if you don't know about the 180 rule, basically the rule that we use to reduce here. You can go to the description and the icon will pop up on your top right if you understand more about 180 rule. So from here, guys, we start. As you can see here, we have these two terms that are divided by cos squared, so we can say 1 minus sine squared theta divided by cos squared theta. This is also divided by the same thing that we see this side, which is 1 minus cos squared theta. Right, so here, guys, we need to use some of their identities, so we're gonna use the square identities. If you still remember, let me show you this. If you still remember, sine squared theta plus cos squared theta is equaling to 1. If you make sine substitute the formula, this is what you're going to have. So if you say sine squared theta and you transpose this cos this side, you will be having the following. You'll be having 1 minus cos squared theta. Right, so this is what you're going to have, meaning that sine squared theta is equaling to 1 minus cos squared theta. Whenever we see 1 minus cos squared theta, we can substitute with sine. Do you guys see that? Right, I hope you can see. But also look at when we use the very same formula here and then we make cos substitute the formula on this one here. If we make cos substitute the formula, we're gonna have cos squared is equaling to 1 minus sine theta squared. Do you guys see this? This is when we took sine to the other side, and then this is what you're going to have. We're going to have 1 minus sine squared theta, meaning now when it's like this, wherever we see 1 minus sine squared theta, we can substitute with cos. If I can draw, I can show you that. Do you guys see? This is the same as that, right? So let's substitute. I hope you guys can see. Now let's substitute. Wherever there is 1 minus sine squared, we're going to substitute with cos squared. So let's write it. Cos squared theta divided by cos squared theta. And then this is going to be divided by, wherever there is 1 minus cos squared theta, we're going to substitute with sine. So this is going to be sine squared theta. Now this cos squared theta divided by cos squared theta is going to give us 1 divided by sine squared theta. As you can see, 1 over sine is actually the reciprocal of cosec. If you don't remember the reciprocals, you can go, guys, to the video that will appear on top there, just to remind you guys, right? So we know that this is same as 1 over sine squared theta. So this is the same as cosec squared theta. So as you can see, this is our final answer. I hope you guys understand this question. I hope you didn't get lost. If it so happened that you did get lost, you didn't understand some of the things, you can rewatch the video or leave a comment, and I will try to answer it to my level best. Alright guys, so we are done with 3.1. Let's go and do 3.2. Alright guys, so this is 3.2. On 3.2 we are given this question here. So it goes like this: if 2 cos b minus 1 is equaling to 0 and sine b is less than 0, calculate this following problem here. So this type of equation, it also needs you guys to understand certain things. So before I explain that, how about I copy this question and then let's do it. Alright guys, so we have copied this 3.2 here so that we can have enough space. So the first thing that you must do here, you need to notice where exactly you're supposed to do all these calculations. You need to find out the quadrat. So this first problem here, or this first trigonometric ratio, it will tell us the one part of the quadrat where you're supposed to do the calculation. So let's make cos subject of the formula here. So if we do the following, we say cos b, or this is 2 cos by the way, and then we take 1 to the other side, it's going to be positive 1, right? And then we say cos b is equaling to, if we divide by 2, it's going to be, so cos b is going to be positive. So this tells us that in a cos diagram like that, cos is going to be positive, right? So where is cos positive? Positive here and there, right? So we need to find out another thing that will help us to choose between the two, because these ones are out, by the way. So when you look at this one here, it says that wherever this calculation will be done, sine must be less than 0. It means that sine, wherever we'll be doing the calculation, will be negative. So sine b is actually negative, guys, right? It's actually negative. So when you look at this quadrat, we have the first quadrat, the second quadrat, sine is positive, but this quadrat on the third one is being scratched out. So we're gonna do the calculations here. So to clarify everything, we're gonna do the calculation on the fourth quadrant, right? So whatever we'll be doing here, it's on the fourth quadrant. Now we need to know what is cot b, cosec b, tan b, and cot b. So that is not a problem. First of all, we need to find out what is our x, y, and our radius, or our hypotenuse. So already with cos, we know that cos is adjacent over hypotenuse. We are all good there. Since this is happening on the fourth quadrant, we can say our adjacent here is x, and then our hypotenuse is r. What is missing is y, meaning our x is equaling to 1 and our r is equaling to 2. So what is our y, right? So our y, we're gonna use the Pythagoras theorem, or theorem of Pythagoras, to find y. So let's do it here. So x squared plus y squared is equaling to r squared. Now if we make y such a formula, we're gonna take x to the other side, and then we're gonna have y squared is equaling to r squared minus x squared. Then from there we square root, we're gonna have y, and then this is gonna be plus or minus r squared minus x squared. Now what is our r squared? So r squared here is gonna be 2 to the power of 2. Then our x squared is going to be minus 1 to the power of 2. So if you put this on a calculator, you will have the following: plus or minus square root of 3. So which one is it? Because you have a plus or minus. Since this is happening on the fourth quadrant, y, this side is negative. You guys see, this side y is negative. So meaning our y here is going to be negative root 3. So now we have x, r, and y. Now it's time for us to do the following. Now if you still remember that cot is the same as x over y, and then cosec is the same as r over y, and then we know that tan is the same as y over x. Well guys, since we have our cot, cosec, and tan in place, we can start now. You can use this formula here. Remember, cot is x over y. So what is x over y? Remember, x is 1. Don't forget that x is 1 here, so it's gonna be 1 over y. So what is our y? Root 3. Negative root 3, by the way, negative root 3. And then plus, so we're gonna add here. So cosec is gonna be r over y. What is our r? Which is gonna be 2 over what? Over y, which is also gonna be negative root 3. All right, I hope you guys can see. And then we have this solid line here that says we are dividing, right? And what is tan? Tan is y over x. So what is our y? Our y is negative root 3. Let me just write it nicely. Negative root 3 divided by x. What is our x? Our x is 1 plus, right, another cot, which is x over y. Our x is 1, and then our y is gonna be negative root 3, right? So as you can see, now it's time for us to simplify this. So we're gonna say, since the denominator are the same, underneath the numerator will add. So we're gonna have 1 plus 2, which is gonna be 3, but let's just write it, and then we have our root 3, right? And then here, since the denominators are not the same, we need to find the common denominator. But as you can see, the common denominator is actually negative root 3. So if you say 1 into root 3, negative root 3 is going to be negative root 3 multiplied by negative root 3, so the answer is going to be 3. All right, plus, right, if you say negative root 3 into root 3, the answer is going to be 1. All right, so let's continue. Now let me just create a little bit of space here, a bit guys, a little bit of space. Right, so I'm going to continue here. So when you, let me create more. So I'm going to continue here. So when you continue on this side, it's going to be 3 over negative root 3. So remember, when you change this into multiplication, they swap, guys, right? So we know that the numerator become a denominator. So the numerator, which is our negative root 3, divided by what is 3 plus 1 is going to be 4. So since these are the same, negative root 3 and negative root 3, they divide each other. So our final answer here is going to be 3 over 4. I hope guys you managed to get this one. It was a bit challenging if you don't understand what is happening here, but basically you were supposed to know how to read the statement here, guys, right? You must be able to read this statement where you are given specific information to identify which quadrant you're supposed to work on. Alright guys, I hope you managed to understand this one. If you didn't understand, you can rewatch on the video and also ask a question, but this time just leave a timestamp when you are asking so that you can know what is it that you are asking. And if you haven't subscribed to the channel, subscribe to the channel, share this video, and let's go into the next question, which is 3.3. All right guys, so this is 3.3. So 3.3, they want us to prove the identity that you see there. So we're just gonna copy this question that I just highlighted and paste it somewhere there is space. All right, just copied this 3.3. So they want us to prove that the left hand side is the same as the right hand side. So the best way of doing this, you must always choose the most complicated side. When I look at this question here, between the left and the right, the most complicated side is the left. So let me just choose the left hand side. Now when I look at the left hand side, you have sec 2a plus tan 2a. So you can change this sec into inverses. So the inverse of sec is actually 1 over cos. So let's do this. Just in case you don't remember the inverses, you can go to the description. I made a video about inverses. So 1 over cos 2a plus. Now for tan, you can change it into its quotient identity, which is sine 2a over cos 2a. Right, so as you can see, these are divided by the same denominator, so let's write it like this. So we can say the numerator, they're gonna add, we're gonna have 1 plus sine 2a, right, divide by cos 2a. Look, sine 2a and cos 2a, guys, are actually double angle identities. I've made videos about double angle identities. They will appear on your description again if you want to understand them, where I derive the double angle identities for sine and cos. Go and watch them if you don't understand them. So let me change this. Let's start with the 1 on the numerator. So we can also change 1 into square identity. Remember, cos a plus sine a squared, is 1 into 1. So this 1 here, we can replace it with that. So let's change it. So let's change. We have cos squared a plus sine squared a, right, plus. Now let's change this double angle identity. So this is going to be 2 sine a multiplied by cos a, right. So we divide this. Let's divide it, right. So this one here also is a double angle identity, so we can change into this one here. We can say cos squared a minus sine squared a, right, because this one is a lot, so you have to be careful when you change this one, guys, the cos 2a. When you look at this numerator, guys, this is actually a quadratic. We can rewrite it like this. Let me just write it here. You can say cos squared a, right, plus 2 sine a multiplied by cos a plus sine squared a, right, divide by the following that is here, guys, which is cos squared a minus sine squared a, right. If you look at this, guys, this is similar to x squared plus 2xy plus y squared. So you can actually factorize this. If we say cos is x and then y is sine, you guys see it's kind of similar to that. I hope you can able to see that, right? So let's factorize our numerator. All right, so if we factorize the numerator there, we'll be having cos a plus sine a, right, multiplied by cos a plus sine a, Let's see if our factorization is correct. If you say cos multiplied by cos, it's going to give us cos square. If you say cos multiplied by sine, we're going to have 1 sine cos. If you say sine multiplied by cos, you're going to have another 1 sine cos. When you add them, they're going to give you 2 sine cos. And then you say sine multiplied by sine, we're going to have sine square. So this is correct. Then underneath here on the denominator, we have the difference of two squares. So let's do difference of two squares. We have cos A plus sine A, and then the second bracket is going to be cos A minus sine A. By the way, this is the difference of two squares, guys. So from here you can see we have cos A plus sine A, which is going to divide this cos A plus sine A, and in the numerator we're going to be left with cos A plus sine A divided by cos A minus sine A. Right, so this, as we can see, this is the same as that on our right hand side. I hope you guys can see that, and I hope this was not as difficult as it seemed. What you needed to know was the double angle identities and the reciprocals or the inverses of the trigonometric ratios, and from there you just substitute and do the basics when it comes to math. Right, guys, if there is a question that you don't understand, you can leave a comment on the comment section, or you can rewatch this video from the beginning of this question until you understand again. Right, guys, let's go and do the last question, which is 3.4. Right, guys, let's look at 3.4. 3.4, they want us to solve for x in the following trig equation. So this is the equation that is given to us. So we also been given the limit where to begin and where to end. So let me just copy this question here, and then let me post it where we can able to solve it. All right, guys, as you can see, this is 3.4. Managed to copy it and place it here. Look, guys, this one here, it's to solve for x. So we are given a domain which is from negative 360 to positive 360, meaning now we will have to circulate the cast diagram 2 times. We are moving from negative 360. Let's try to write it when we're from negative 360 to 0, right, to 0. So this one is when we are moving from negative 360, which is gonna be somewhere here, and then we move to 0. So this is how it's supposed to look like. That's the first negative 360 there. We must get the angles that belong here, right? So we know that when we are moving backwards, this is going to be negative 90, and then this is going to be negative 180, and that is going to be negative 270, and that is going to be negative 360, right? So this quadrant here, the fourth quadrant, we represent it by negative theta. The third quadrant, remember we are going backwards here. The third quadrant, we are representing it with negative 180 plus theta. And then the second quadrant, we're going to represent it with negative 180 minus theta. And then the last quadrant is going to be negative 360 plus theta. Remember, when we are moving from negative 360 to 0, so these are the quadrants. When we are moving from 0 to 360, remember, now the first 360, it's dealt with, the negative 360. Now it's time for us to move from 0 to 360. So this is going to be 0 to 360, right? So again, now these are going to change. Now this is going to be 90, it's going to be 180, and that is going to be 270 and 360. So we're going to continue move like that. Now on this cycle, guys, on this cycle, we're going to be representing the first quadrant with theta. This one here we're going to represent with 180 minus theta. This one here we're going to represent with 180 plus theta, and this one here is going to be 360 minus theta. Right, so don't forget, this is the first cycle, and that one is the second cycle. So let's solve this. As you can see, this is a quadratic equation, so you can try to solve it as if you are solving it. So we can factorize this like this. We can say 2 sine x, right, on the first bracket. On the second bracket you can also put sine x there. When you look at our constant is 1, so we can say 1 here, because if you say 1 multiplied by 1, you're going to have this one. If we say 2 sine x multiplied by sine x, you're going to have 2 sine x squared. And now, which one is going to take the sign in the middle? If we say 2 sine x multiplied by 1, you're going to have 2 sine x. So if you make this one negative, you're going to have 2 sine x multiplied by negative 1 is going to be negative 2 sine x, and then this one become positive, because if you say 1 multiplied by sine, it's going to be sine, so they're going to give us that. Right, so this is equaling to 0. So from here, guys, you have to solve for x. So let's start with this one here. So this one here, we can say 2 sine x is equaling to negative 1. If you transpose this one to the other side, and this one here, we can say sine x is equaling to positive 1. Right, then from here we have to left with only sine. We divide by 2. When you divide by 2 on this one, you're going to be left with sine x negative 1 over 2. This one here is still fine as it is, so let's just write it. So from here we say arc sine. So when you take sine to the other side, it becomes arc sine. So this is going to be arc sine. Never mind the negative, just put half there, because you're trying to find the reference, guys, right? And then here also we're just gonna say x is equaling to arc sine 1, right? So we know that this is gonna give us 30. In this case, this 30 is actually a reference, right? Even here we're gonna have 90. Right, so before I continue solving the x's that we are looking for, let's look at this part here. I just want to explain something. We have sine, which is equaling to a negative half. So for this one here, for this one, we are looking for the quadrant from negative 360 to 360, where sine is going to be giving us negative half. So what are those angles that you're looking for, right? So 30 is our reference, right? And then on this one here, as you can see, we are looking for the angles that will give us positive. What are those positive ones? So what are those angles that we will find from negative 360 to 360, that when we substitute them here, they're going to give us positive 1. So this is going to be a bit longer. I need you guys to bear with me. So you need to understand, for this one we must look at the quadrant where sine is negative. So let's start with this one here, where sine is equal to negative 1 over 2. So our reference is 30, by the way. So sine is going to be negative on the fourth quadrant and the third quadrant, but it's positive here, guys, right? So for this one here, let's do it. So how do we represent this quadrant? Since our x is our reference, this one we say it represented by negative theta. So our theta here is 30. So we can say the first answer is negative theta. Right, that's the first answer. The second answer, remember, sine is negative here. So how do we represent this quadrant? It's x negative 180 plus theta. What is our theta here? Our theta is 30. So you're going to put the reference angle, and then we know that it's going to be negative 150 degrees. Okay, let me just create more space. All right, so this is where sine is going to be negative. Now let's look on the second cycle. Again, sine is negative here and there, right? But positive there and there. Right, now we are moving from 0 to 360 now. So how are we going to do this? On this cycle here, we know this is going to be, remember we are moving this way this time around. It's going to be x is equal to 180 plus theta, which is our reference. So it's going to be 210 degrees. Right, last but not least, as you can see, sine is negative here on this quadrant. It's going to be 360 minus 30. So as you can see, this is going to be 330 degrees. Guys, these ones here, these answers that we got here, if we substitute them on sine x, we will have negative 1/2. Alright guys, that's how you do this one here. Okay guys, what about when we have sine x is equal to 1, where sine is going to be positive? So we're going to look at on the very same quadrant here where our sine is positive. So sine is positive on the first quadrant and the second quadrant. Right, so let's start on this one here. So you're going to do the very same thing here, guys. This is how we represent this quadrant. When you go backwards, it's going to be negative 360 plus theta. So let's do it here, guys. Let me just try to do it here. So x is going to be negative 360 plus theta. What is our theta? It's 90. There we go. It's 90. So our answer is going to be negative what? 270. As for when we go to positive side, it's going to be this 90. So as for this one, it only has two answers here. It has 90 and negative 270. Guys, this is how you do this problem here. I hope you are not confused, guys, because it is a lot of things that you need to know. Just in case you didn't understand, you can leave a question on the comment. Also, don't forget to like the videos, subscribe to the channel if you haven't subscribed. If you didn't understand, rewatch the video again so that you can understand better. Right, as you can see, here is our question 4. It consists of question 4.1, 4.2, 4.3 and 4.4. So we're going to do all these questions on this video. Now let's start with 4.1. What is it that they want us to do here? As you can see, they want us to determine the following limit. So as you can see, these are more trigonometric ratios on this limit. So I will copy this question and then I will paste it somewhere with the space so that we can able to do this. All right guys, as you can see, this is 4.1. so the following limit, as you can see, they say x approaches 0. Now before I show you guys how to solve this, there is a playlist of limits where I explain or show you all the types of limits that you must do, or the type of steps that you must do when you do limits. So I'm gonna leave that playlist on the description, and also the icon will pop up on the top right there. Just go and watch those videos if you want to understand more about limits. But the first step you must do here is direct substitution. Since our x is approaching 0, so you're gonna rewrite this equation here, and then wherever there is x, you substitute with 0, right? So let's do that. So when you substitute with 0, obviously this is gonna be 0. So if you get 0 like that as an answer, it means now you must try step number 2. So step number 2, guys, you actually have to simplify. Can we able to simplify this equation here? Yes, we can. Now let's look at the numerator of this limit. So you're just gonna write limit, right? X approaches 0, and then you look at the numerator. What is happening here on the numerator? If you pay attention, this is actually something that we can change by using the square identities. We know that sine squared x plus cos squared x is equaling to 1. So if we make sine squared x subject of the formula, we're gonna have 1 minus cos squared x. So we can substitute wherever there is sine squared x with 1 minus cos x. So let's do that. So we substitute that with 1 minus cos squared x, and then we divide by our 1 minus cos x. Right. So guys, you have to be careful when you do such problems. Now when you look at the same numerator that we have here, we have 1 minus cos squared x. So this here, guys, is a difference of 2 squares. So let's continue. Let's solve this further. All right, so if you continue like this, you're gonna have the following: 1 plus cos x, then the second bracket is gonna be 1 minus cos x. Right, if you remove the brackets here, they're gonna take you back to the one on the numerator there, and then we have on the denominator 1 minus cos x. Right, as you can see, 1 minus cos x divided by 1 minus cos x, you're gonna be left with 1 multiplied by 1 plus cos x. So if we continue here, we're gonna be having the following: x, by the way, is approaching 0. We're gonna be left with 1 plus cos x. Right, so from here we start substituting. After simplifying, we substitute. So wherever there is x, we substitute with 0. So let's continue. So if you substitute here, you're gonna have 1 plus cos, then wherever there's x, substitute with 0, then that is that. So if we continue here, we know that this is gonna be 1. What is cos 0? It's gonna give us 1. So the final answer is gonna be 2. Guys, as you can see, this is not a challenging problem. It's very straightforward. You need to remember the steps that you must follow when you get the limit of an equation. Alright guys, so I hope this helps you to understand. If you don't understand, you can go back to the beginning of this question and rewatch wherever you got lost, or you can leave a comment if there's something that you didn't understand. Hopefully I was able to clarify. Alright guys, if this question was simple for you, don't forget to like the video, and also don't forget to subscribe if you haven't subscribed to the channel. So we have done with 4.1. how about we do 4.2? Alright guys, as you can see, this is 4.2. now 4.2, the one has to expand this expression that you see here. So they never mention to what term. Just in case you don't know, if they say expand without specifying, the safe bet is to expand to the fourth term. Usually the fourth term is the maximum expansion number that they require you to do that, unless they specify. If they don't specify, end up on the fourth term. Now let's copy this question. Alright guys, so as you can see, they want us to expand this. So in order for you to expand this, you need to simplify this so that it can look like something like this: x plus h to the power of n. Right, so as you can see, this doesn't look like that, so that we can use this formula here, the binomial theorem. Just in case you don't remember the binomial theorem, I've made videos on binomial theorem, so you can go and watch those videos based on binomial theorem. I've explained how this formula came about, or how to derive this formula that I'm writing here. So you can go to that video and watch it. So I'm gonna leave that video on the description, and you go and watch it. And also it's gonna pop up on your top right there. So go and watch that video so that you can understand way much better about this binomial theorem. Okay, so this is the formula. Hopefully I will have enough space to write it here: x to the power of n minus, let's create more space, n minus 3 h to the power of 3. So this is a binomial theorem for expansion. So since they never mention to what term, the best term is the fourth one, so leave it on the fourth term. So let's simplify this and then let's expand by using this formula here. So first of all, you know that 1 over x plus h to the power of 5 can be written as x plus h to the power of negative 5, right? So as you can see now, this kind of looks like that up there, so we can able to use this formula there. All you have to do is just substitute. Don't forget that n is actually the power of negative 5. So let's expand it. So I'm gonna expand it here. So first of all, we're gonna put x as x, and then since n it's the negative of 5, we're gonna write negative of 5 there, then plus, then here we have negative of 5 as the second term, and we have x to the power of negative 5 minus 1 multiplied by h, by the way. And then we go to the third term, which is gonna be negative 5 multiplied by negative 5 minus 1, right? Factorial 2, or 2 factorial, multiplied by x to the power of negative 5 minus 2 h to the power of 2. The last term, which is the fourth term, I would advise you to stop here. It's gonna be negative 5, remember this is n, multiplied by negative 5 minus 1, multiplied by negative 5 minus 2, and then this is divided by 3 factorial, multiplied by x negative 5 minus 3 and h to the power of 3. Guys, as you can see, what I did here, I just substituted the negative 5 as our n. Wherever there is n, if you can pay attention on this formula here, we substituted with negative 5. X is x and h is h. So we start calculating. So when we use our calculators for the first term, we don't really need to use a calculator. It's gonna be x to the power of negative 5. And then our second term, as you can see, this 5 is negative, so this is gonna be negative 5. Now we have x to the power of negative 5 plus 1 is gonna be x to the power of negative 6 multiplied by h. Now since we have negative multiplied by negative, this becomes positive. Now if you put this on your calculator, guys, you're gonna have, let me just highlight very quickly. If you put this on your calculator, right, when you have negative 5 multiplied by negative 5 minus 1 divided by 2 factorial, the answer that you're going to get is going to be 15, right? And then we have x to the power of negative 5 minus 2 is going to be negative 7, and h to the power of 2. Now again, on this one we do the very same thing, guys. You take all this, you put it on your calculator, which is what, which is negative 5 multiplied by negative 5 minus 1 multiplied by negative 2 minus 2 divided by 3 factorial. This here is gonna give you negative, okay, let me just remove that block. It's gonna give you negative 35 x. Now we have x to the power of negative 3 minus 3, which is negative 8, multiplied by h to the power of 3. Right, so this is what we have, but this is not the end of our expansion. You need to write this in the right way. So this is 1 over x to the power of 5. Since our exponent is negative, rather leave it in a positive. So same thing here, we're going to have negative 5, and then we have x to the power of 6 multiplied by h, and then here we have plus, and then we're going to have 15 over x to the power of 7, and then we have h to the power of 2. Last term is going to be negative 35, and then we have x to the power of 8 multiplied by h. 4.3. All right guys, this is how you do this one here. I know it might look very long and complicated, but really it's not. All you need to know here is the binomial theorem. So if you are not so sure about binomial theorem, there is a video, in fact there is a playlist of binomial theorem where I show you how to expand and also explain the formula there. Go and watch that playlist and make sure you understand. You can come back here and rewatch this one or do it on your own. Alright guys, if this video helps you to understand this question, do not forget to like, subscribe, and also share this video to your friends. Now that we are done with 4.2, how about we do 4.3? Alright guys, so it's time for us to do 4.3. As you can see, 4.3, they say use first principles to differentiate the following, guys. Y is equaling to x to the power 4 minus 3x plus 6. So I'm going to copy this question and we're going to paste it where there is space. All right guys, so this is 4.3. so they want us to use the first principle to differentiate the following here, guys. So before we do this, you need to know exactly what is the formula that you're gonna use when we differentiate using the first principle. So here's the formula, guys. Let me write it here. It goes like this: f of x prime is equaling to f of x plus h minus f of x, and then you divide this with h, and then you say limit h approaches 0. So this is the formula that we're going to use. Just in case you don't know what this is, I already made videos about this, guys. You can go to the playlist. There is a video where I explain exactly how we use this formula here, but I'm gonna try to explain as much as I can also here. So first of all, in order for you to use this formula, you need to know what is f of x, and also you need to find f of x plus h. So f of x, you don't have to worry because f of x is given to us here. So if I were to write this, this is the same as f of x. So f of x is the same as x to the power of 4 minus 3x plus 6. This is our f of x. Now f of x plus h, you need to calculate it. So f of x plus h, when you do it, you're gonna do the following. You're gonna take the very same formula that is given to us, but wherever there is x, you substitute with x plus h. So let's do it. So as you can see, we have x to the power of 4, so meaning we're gonna have x plus h to the power of 4 minus 3. So wherever there is x, we're gonna put x plus h plus 6. So basically this is how you do this, but it's not as easy as it seems here, guys, because you need to apply binomial theorem in order for you to factorize this one. You have to expand this one. In fact, you have to factorize this and expand it. So the best way, guys, the best way so that you can save time, expand this to 3 times. Don't go beyond 3 times. It's useless for you to go beyond 3 times because time is what you are working against. So rather go to 3 times, right? So let's do this. Just in case you don't know about the binomial theorem, there is a formula that you need to use for binomial theorem when you expand. So again, you can go to the playlist and go and watch the videos about binomial theorem. I made lots and lots of videos there. So first of all, the formula is like this. You're gonna have x to the power of n plus, and then we have n multiplied by x to the power of -1 multiplied by h, right? And then the next term is gonna be plus, now it's n multiplied by n minus 1, right? And then this is divided by 2 factorial, and then from here you say x to the power of n minus 2, and then you say multiplied by h squared. From here now you just come to this part here. You can see -3 multiplied by x, you're gonna have -3x, -3 multiplied by h, you're gonna have -3h, and then plus 6, right? Now this formula that I just wrote here, guys, you must able to substitute here. So n is basically this 4. That n here that you see here there and there and there is basically the exponent 4 here. So let's just substitute. So wherever there is n, we substitute with 4. So we have x to the power of 4, the n that I'm talking about here, plus, now here you have 4, and then you have x to the power of 4 minus 1. Don't forget, multiply by h, plus, now this time around you're gonna have 4 multiplied by 4 minus 1 divided by 2 factorial, then multiply by x to the power of 4 minus 2 multiply by h squared. Then from there you just continue with this, minus 3x minus 3h plus 6. I hope you can see this, guys. I know this is so small, but I'm trying to save space for when we substitute them. So guys, as you can see, I didn't mention this is the first term, second term, and the third term. Don't go beyond that, you don't waste time. So the first term is gonna be x to the power of 4, the second term is gonna be plus 4, but when you look at the exponent there, it's gonna be x to the power of 4 minus 1 is gonna be x to the power of 3 multiplied by h. Now this one here is gonna be plus. Now you take your calculator, then you insert 4 open bracket 4 minus 1 close bracket divide by 2 factorial, and then when you do this, this is gonna give you 6, right? And then you look at your x, you have 4 minus 2 as an exponent, so it's gonna give you exponent of 2, so you have x squared, and then multiply by h squared minus 3x minus 3h plus 6, right? So basically this is our f of x plus h. I hope you guys can see it. It's very long, but this is how f of x plus h look like, right? So from here we have to take this f of x plus h and substitute it there, while we also need to take this f of x and substitute them. So like I said, this needs more space, so let me try to continue here. So we're gonna try to continue here. So while you're busy substituting, the f of x prime limit h approaches 0, you need to write this information here, and then from here you put your f of x plus h, which is all this long thing here. Let me just underline it as well. This is f of x plus h, so you put it here. So let's do it. So it's gonna be x to the power of 4, right, plus 4x cubed multiplied by h plus 6x squared h squared, right, minus 3x minus 3h plus 6, right? So this is f of x plus h. Now it's time for us to substitute with f of x. Don't forget this is minus, so when you substitute f of x, put it in the bracket because this negative is affecting f of x. So whatever that is f of x must be inside the bracket. So it's going to be x to the power of 4 minus 3x plus 6. There we go. And all this is divided by h. Now the second step is to multiply by the negative here to remove the bracket. So let's do it. I know this can be long and frustrating, but we have to do it this way, right? F of x prime, then you don't forget to write limit and h approaches 0. So let's do this. So this time around you're just gonna write f of x plus h as it is. So let's write it, guys. Let's try to be quick so that you can able to finish this quickly. All right, so this is gonna be like that, right, plus 6. So here we just multiply by negative, so this become negative x to the power of 4, this become positive 3x, and that becomes negative 6. All this is divided by h. Now what we can do here, guys, is it's time for us to find the like terms and subtract them. What you should know here, guys, to check if you did the right thing is all the terms that have h must remain, and all the terms that don't have h with them, they must cancel. So let's start with x to the power of 4. There's no h there, so this positive x to the power of 4 is gonna cancel with negative x to the power of 4. You guys see? And in the second term it has h, we skip it. The third term it has h, we skip it. We come to the fourth term, we have negative 3x, there's no h here, it's gonna cancel with positive 3x here. And then we come to negative 3h, which we skip it, and we're gonna come to plus 6. Plus 6 is gonna minus with negative 6. So what you should be left with, again, to double check, it should be all the terms with h here. So let me just create a little bit of space, guys, because we don't have space. All right, let me just create a space here. Right, so when you continue, do not forget to write prime, f of x prime, then you write the remaining on the numerator. So let me just write limit here, and then write h approaches 0. So what do we have there? Let me just put in a line there, guys. We're gonna have 4x cubed multiplied by h plus 6x squared h squared minus 3h. This is what we're left with, guys. If it so happens that you're left with any term that doesn't have h, you've made a mistake somewhere there, you must go and check here, or your f of x plus h, then divide by h. So from here, guys, as you can see, the numerator, it has h all the terms, so you need to take out the common factor, which is h. So we're gonna continue to write f of x prime, and then we gonna take out h as a common factor. So the first term is gonna be 4x cubed plus the second term is gonna be 6x squared h minus 3, which is the third term. Right, remember we took out the common factor, divide by h. Right, now as long as we haven't substituted h, we must write this limit and h approaches 0. Right, so let's continue, guys. Let's continue. As we continue now, look at this h and that h, they will divide each other, and then now what are you left with here? F of x prime, you're gonna be left with 4x cubed plus 6x squared h minus 3. Right, limit h approaches 0. So from here, the next step is to substitute h with 0. So wherever we see h, we must substitute with 0 because h is approaching 0. So you're gonna write f of x prime, right, and then wherever there is h, you substitute with 0. So you're gonna have 4 multiplied by x to the power of 3 plus 6x squared, but wherever there is h, we substitute with 0 minus 3. So the final answer, let me just write it here, f of x prime. Oh, by the way, whenever you start substituting, the limit and h approaches 0, they fall out, guys. Then so the answer here is gonna be 4x cubed minus 3. Look, this was one of the questions that was very long. I hope you guys managed to see and understand it. I try to explain the question the best that I can. If it so happen that you didn't understand, guys, this question, you can go to the beginning of the video or the beginning of the question, by the way, and then rewatch it again. And if you still can't understand, you can leave a question on the comment section and ask. Hopefully I will be able to help you to my level best. But if this video managed to help you on this question, do not forget to like and also share the video to your friends as well. If you haven't subscribed, subscribe to the channel, guys, because I've made lots and lots of videos. So we are done with 4.3. how about we do 4.4? all right, guys, so on this question 4, here is our 4.4. So 4.4, they want us, guys, to differentiate the following problem here. As you can see, this is one of the longest differentiation that we're going to do on this video. So I'm gonna copy this question and paste it where there is space so that we can do it. Alright guys, as you can see, this is 4.4. So we need to differentiate this problem here, guys. Right, so before I start, you need to be able to recognize these terms here. Which method or which law are we going to use to differentiate this term? Now, if I look at the first term and the second term, these are exponential because x is an exponent when it comes to these two terms here. And then when I look at the third, the fourth, the fifth, and the sixth, all these are trigonometrical differentiation. So we need to use trigonometry to differentiate this. And then when I look at the second last, this is actually the natural log differentiation. So I need to know the derivative, the natural log. And then this one here, which is the last one, is actually the power rule. So you have to be able to notice and recognize those differentiations, guys. Okay, so now if you don't know, I've made videos on all of these rules or laws of differentiation. You can go to the playlist and watch those videos here if you don't understand what I'm about to do. But then another thing that you need to do, you cannot differentiate with some of the terms the way they are. For example, term number 1, 2, 3, 4, 5 and 6, they need to be simplified. So let's first simplify it. So while you're simplifying, you equate everything to 1. Start with term number 1. You have 3 as a numerator. You need to take this 2 to the numerator. So when you take this 2 to the numerator, the exponent becomes positive. That's how we can able to differentiate this one. Same thing with the second term here. We have pi. Now we need to take this e to the numerator, but the exponent now, the sign will change. We're going to have negative 3x. And then when you come to the third term, we have 1 over cosec. This is an inverse of sine. So you write sine 3x. Same thing on the next one here. We have 1 over cot, which is an inverse of tan x. Right, what about the other one? It's also an inverse. 1 over sec, it's an inverse of cos x. Right, but this one here, we need to deal with sine 2x. This is a double angle identity, so you need to solve this. You need to write this double angle identity. Just in case you don't know the double angle identities, I've made videos on them. So this is actually sine x multiplied by cos x divided by cos x. Right, and then this one is fine. You just write it as it is, 3 over 2 multiplied by natural log x. And the last one as well is also fine. We have 1 over 3p. So when it's like this, now we know that this term here, we have cos and cos x, they're going to divide. You're going to be left with 2 sine x. So the best way is to rewrite it again, guys. Rewrite it again. So we're going to have 3 multiplied by 2 to the power of x plus pi multiplied by e to the power of negative 3x minus sine 3x plus tan x minus cos x. So here we are left with plus 2 sine x, and this one here is 3 over 2 multiplied by natural log x minus 1 over 3p. It's long, guys, I know it's very long. So from here we start differentiating. So this is exponential derivative. So when you differentiate, guys, you must say dy over dx. We are differentiating with respect to x, even though they didn't mention here. Okay, so let's do it. So when you differentiate the exponent, here's what you do. You multiply it by the coefficient of x to the coefficient of the base. So the coefficient of x is 1, so even if you don't write it, it's going to be 3 multiplied by 2 to the power of x. Then you introduce natural log, then you put the base here, natural log 2, and then you do the same thing on this one. As you can see, the coefficient of x here is negative 3. You multiply the coefficient of x with the coefficient of the base. In this case, the coefficient of the base is pi, and then you multiply the base and then the exponent there, and then do not forget to introduce the natural log, which is natural log. Then we also put the base, which is e there, and then we come to this one here. We have negative sine 3x. So again here you're gonna put negative, you multiply by the coefficient of x, which is gonna be 3, and then what is the derivative of sine? It's gonna be cos 3x, right? So we come to tan now. Tan, the derivative of tan is actually sec squared x. Guys, this is there on the formula sheet, so you don't have to worry about it. Even the derivative of cos is actually negative sine x. It's also there on the formula sheet, guys. You're supposed to know that one. So here, what is the derivative of sine? As you can see, we have a coefficient which is 2. What is the derivative of sine? It's going to be positive cos x. And then when you come to this one here, the coefficient here is 3 over 2, as you can see. Now what is the derivative of natural log? It's actually 1 over x, right? I also made a video on this one, you can go and watch it on the playlist. And then we come to this last term. The last term, as you can see, we are differentiating in respect to x, so there is no x here, so this is equal to 0. So it's time for us to simplify this. So let's simplify it, right? So the first term is fine. When I have 3 multiplied by 2x natural log 2, this one we have negative 3, so it's going to be negative 3 multiplied by pi, then e to the power of negative 3x. But natural log e is 1, even if you don't write it, it's fine. So we come to this one. This one's going to be negative 3 cos 3x, right? And then this one, you just write it as it is, going to be sec squared x. Negative multiplied by negative for this one is going to be positive, and then sine x. And then this one is going to be plus 2 cos x. And this one we're going to have 3 multiplied by 1 is going to be 3, and then on the denominator we have 2 multiplied by x is going to be 2x. Then you leave it like that, even if you don't continue, because the last one is 0. Then you look for the like terms. If there's no like terms, so this is our final answer. Guys, I know this was one of the longest question ever, but I'm glad if you managed to understand this. If it so happened that you didn't understand, you can restart this question and rewatch it again, because some of the things that I did here, you need to watch the basic when it comes to this derivatives, which I made videos on. Go to the playlist, you'll be able to find those ones. But then this is how you actually do this one. If this video helped you to understand, do not forget to like, subscribe, and also share this video to your friends. If you haven't subscribed, subscribe to the channel, guys. So this is the last of question 4. We'll be doing question 5. Right, so this is question 5. So we're gonna start with 5.1, where we are required to sketch and calculate the magnitude of the area enclosed by the curve y is equal to sine x for x is greater than 0 degrees or equaling to it, and x is equaling to or less than 180 degrees. So I'm going to copy this question here, and I'm going to paste it where there is a space, because we are required to sketch a graph here. Alright guys, as you can see, I've already copied this question and pasted it here. So the first thing that they want us to do here, guys, is to sketch the graph of sine x, and then we are given a range. So this range here, it requires us to draw a graph from 0 degrees to 180 degrees. So before I start though, I just want to show you the general formula for trigonometric ratios. So here's how the trigonometric ratios are supposed to look like. So we have y, and then we have a. Our a, by the way, is actually an amplitude, and then in this case, since we are dealing with sine, we're just gonna write sine, the trigonometric ratio, and then we're gonna have b. B represent the number of periods within 360, and then we have x here. We have plus or minus theta. So theta actually represents the shift of the graph on the x-axis or on the range, and then we have plus or minus c, which is the shift of the graph on the y-axis or the domain. So guys, I hope you can able to see what is happening here. So let's look at our question there. They say y is equaling to sine x. There we go. So look, we have to find our amplitude. We need to know the period for complete cycle, and also we need to know the intervals and everything that is necessary for us to draw the graph. So I'm just gonna do the calculations here. So first of all, as for amplitude, there is 1, so our amplitude is gonna be 1. As for the period within 360, what is it? It's gonna be 1. That is actually b. Remember, b represents the period within 360. As for theta, there is no shift there, and also we are not shifting vertically and horizontally, so we are fine. So we need to calculate the period. So for the period, there is a formula. Period is equaling to 360 divided by b. So our b here is 1, so the period is going to be 360 divided by 1. So our period is actually 360 degrees. I hope you guys know this formula. Alright, so this means that our complete cycle for sine graph is gonna be within 360. One complete cycle, guys, is gonna be within 360. Now remember, our sine graph looks like this. Let me just draw something here. It looks like this. It will turn and cut and turn and cut. So as you can see, our graphs start from 0. It turns here, it cuts here, it turns here, and also cuts here. So we need to know these values where it turns and cuts. So in order for us to know that, there is a formula that we're going to use, which goes like this. In fact, these we call them the intervals, right? The intervals. So it's period divided by 4. For sine graph, this is how you do this formula here. So what is our period? P is 360 for this one, and then divide by 4, right? So what is 360 divided by 4? This is gonna be 90 degrees. All right, guys, so now it means from one point to another they must be separated by 90 degrees. So we have our interval and we know how our graph is supposed to look like. But don't forget, our range state that our graph should be within 0 and 180. So let's draw our graph here. So let's look at our graph. I'm gonna use a different color. So we start at 0, and then we're gonna turn at the next 90. Remember, our interval it's 90, so the next 90, y where is 1 and our x is 90, so this is the point there. And then we're gonna cut again where on the next 90, so 90 plus 90 is gonna be 180, so this is where we're gonna cut again. So when you draw our graph, it's supposed to look like that, right? So we don't continue and do 270 and 360 because our range says from 0 to 180. There's no need for you to do that, guys. So from here you highlight the area, okay, or you shade it. So let's shade the area. So our area, it is shaded. Then from there, don't forget to write the strip, guys. Here, just write the strip. So the strip for now, don't worry that much about it, as long as it's within the area that we are required to calculate. Some of you may put it here, some of you may put it in the middle, but as long as you show the strip here, the representative strip. Right, guys, so from here, what is it that they want us to do now? They want us to calculate the magnitude of the area enclosed by the curve. So we do have the curve here. Now when we calculate, we're gonna use the definite integrals. I've made videos on definite integrals. I hope you will able to see them. I will leave the videos on the description, and also on the top right the video will pop up there, guys. Right, so let's look at this. Now we must have an upper limit and a lower limit. So our upper limit in this case is going to be 180, and then our lower limit, since it starts from 0, is going to be 0. And then what are we integrating? We're going to integrate this sine x dx. Right, so from here, guys, what is the next step? So the next step is to integrate this here. So let's integrate. So when you integrate, remember the definite integral, we do not have c. Even if you don't include c, it's fine, guys. Remember, c is for indefinite integral. So when you integrate, what is the integration of sine x? If you still remember, the integration of sine x is supposed to give you negative cos x. So it's going to be negative cos x. Since these are definite integral, don't forget to write your upper limit here and the lower limit there. So from there, we do the following steps. So the following step is going to be y is equaling to the upper limit is going to be subtracted by the lower limit. So we're going to write the upper limit cos x with 180 minus cos x with the lower limit, which is 0. So from here, guys, we substitute our x's with the limit. So for the first bracket is going to be x, which is going to be substituted by 180 degrees, and for the second bracket the x is going to be substituted with a 0 degrees there. So let's do it. So on your calculator, this is what you write: cos 180, wherever there is x for the first bracket, you put cos 180, and then on the second bracket you're going to put negative cos 0. Do you guys see? Then there from your calculator, this must give you 2 unit square. Remember, we're actually calculating the area, so you can equate it to y or a, but at the end of the day we are calculating the area. Guys, this is how you calculate the area of the given problem here on question 5.1. I hope you managed to understand, guys. If it so happened that you did not understand how we do this one, don't forget to ask a question on the comment section and I'll able to answer you, or you can go back to the beginning of the video where we start this question and rewatch it again. I hope this was helpful, guys. Do not forget to like, subscribe, and also share this video to your friends. Now that we are done with 5.1, how about we do 5.2? Well, guys, let's do 5.2. When I look at this question, it looks very familiar. I think I've done this question alone when I was dealing with definite integral. So I think if you can go to the definite integral playlist, you'll be able to see this one. But anyway, let's just do it since we are dealing with question 5. So I'm gonna copy this question here and paste it somewhere where there is space, so we start to evaluate this problem. Alright, guys, so we already paste this question here, 5.2. As you can see, they want us to evaluate this. These are actually definite integrals. I've made a video on definite integral. You can go to the description to watch the intro of those videos, and also you can go to the icon that will pop up on the top right and watch the intro on definite integral. Alright, guys, so before we integrate, though, you need to identify what type of integral is this one here. As you can see, this is exponential because our x here is exponent. Now you need to go back and watch the videos where I explain the type of integral. So if you still remember, if you are given something like this, a, which is a base, and then we have n, the coefficient of x, and x as an exponent, dx, and then they say integrate this, the formula that we're gonna use is gonna be a to the power of n x divided by n, then natural log a. This is the formula that we're going to use, plus c. But since we are dealing with definite integral, this c is not part of our integration. So guys, I hope you still remember this. Just in case you don't remember this, I will leave a video on the description and also on the icon on top there. Go and watch that video so that you can be able to remember this. So let's integrate this problem here. So we're gonna equate this. Remember guys, when you integrate, the sigma falls out and the dx, do not forget that, guys. Right, since we are dealing with definite integral, we just put the bracket there. So let's do it. So you're gonna rewrite this 3 to the power of negative 2x on the numerator, and then on the denominator we have n, which is gonna be negative 2, and then we say natural log, and then what is our a, which is gonna be our base, which is 3 here. And then do not forget, then here you're gonna write the upper limit and the lower limit there as you are given there, guys. Right, so the next step, now you subtract the brackets of each limit. So minus, don't forget this minus here, we have 3 to the power of negative 2x divided by 2 natural log 3. And then on the first bracket, this is gonna have the upper limit, which is minus 1, and then we minus, and then don't forget the first bracket is for the upper limit and it's going to be subtracted by the second bracket of the lower limit. So let's not forget this one is also negative, by the way. So it's going to be minus 3 to the power of negative 2x over 2 natural log then 3, and then this is the bracket for the lower limit, which is 0. From here, the only thing that is left for us, guys, is to substitute wherever there is x there. So let's do it. So the first bracket, we know that it's going to be minus 3 to the power of negative 2. Wherever there is x, we put negative 1. There we go. Divide by 2 natural log then 3. Right, and then minus and minus, that is going to give you positive. So this is going to be the power of the base is going to be 3 to the power of negative 2. Wherever there is x, it's going to be 0, and then we divide by 2 natural log then 3. Right, so from here, guys, you just use your calculator. What is it when you substitute this on your calculator? So the answer is going to be negative 3,641. So that is your evaluated answer here, guys. I hope you can able to understand this one. I think I've made a video on this question specifically. If you can search on the playlist, you can able to see this video where I explain again, but also I've explained enough here, guys. Alright guys, if you understand this question, do not forget to like and also share the video, and also subscribe if you haven't subscribed to the channel. And guys, let's go and do question 5.3. Alright guys, so let's look at 5.3. As you can see, 5.3, they want us to integrate the following. We have this long polynomial integration. So let's just take this and paste it somewhere where there is space so we can able to do it. Alright guys, so this is 5.3. as you can see, now we have this polynomial. We need to integrate this. By the way, this is the indefinite integral. Remember, we don't have limits here, so this is indefinite integral. So first of all, before you do this integration, you need to look at each and every term, and you need to notice or make sure that there's no term that needs any simplification. When I look at these terms here, there is one term that needs simplification, which is this one here, guys. Right, so while we are simplifying, we need to keep the sigma and the dx. So let's first simplify this one. So the sigma and the dx, they remain there. We're just gonna write our e to the power of 3x plus 3a to the power of 3x as well, minus 10 to the power of 2x plus. Now this one here, we need to change this. We cannot integrate with the side like that, so we need to write 1 over. So if you change this into exponent, this is gonna be x to the power of 1 over 3, right? So now when it's like this, we also need to change it. We cannot integrate when we have the x as a denominator. So pay attention, guys. As long as I'm simplifying, the sigma and the dx are still there. So keep them, guys, keep them, because this kinda indicates that we haven't yet integrated. So we have e to the power of 3 plus 3, and then we have a to the power of 3x minus 10 to the power of 2x. Now when we take the base to the numerator, the sign of the exponent changes, so it's gonna be negative 1 over 3. I hope you guys know this. These are exponents long. All right, so when it's like this, we can now start integrating. Now before we integrate though, I would like you guys to pay attention to each and every term that you see here, because these terms here, they won't be integrated in the same way, guys, right? So for the first 1, 2, 3, these are exponential integration, because when you look at the exponents there, the x is the exponent, and don't forget we are integrating with respect to x, hence we have dx there. And then the last one, it's actually the power rule. Okay, before we start, guys, I need to show you the formula that we're gonna use for this exponential integration. So if you are given something like this, k, which is the coefficient of the base, and then we have a, which is the base, and then we have n, which is the coefficient of the x, and then we have x there. This is basically the exponential integration here. So when you integrate this, you're gonna have k, the coefficient, and you're gonna have a to the power of nx, divide by, now this n is gonna be here, and then we introduce natural log, then you write the base plus c. Since these are indefinite integral, we need to include c there. So for exponential integration, we're gonna use this formula, which are 1, 2, 3. We're gonna use this formula here. So let's use the formula, guys. So let's start with the first one. So whenever we start to integrate, the sigma and the dx, they will follow. Right, so let's start with the first one here. So what do we have here? We're gonna have e to the power of 3x, right, divide by, right? So when we divide, we know that the n here is 3, and then we're going to have natural log, then we say e, right? So we are done with the first one here. We go to the second term. So the second term, we have 3 multiplied by 8 to the power of 3x. So we're just going to write 3 multiplied by 8 to the power of 3x on the numerator, but then we're going to divide by, what do we have here? Our n. Our n is gonna be 3, the coefficient of x, and then we introduce natural log, and then our base is gonna be 8. Right, so we go to the next term, which is the third term. Now what do we have here? We have 10 on the numerator to the power of 2x, and then we divide by 2, which is n, right? And then natural log, what is our base here? Our base is gonna be 10. Now let's do the last one here, which is the power rule. The power rule, guys, just in case if you don't remember, the power rule, it looks like this. If you are given k to the power of x, maybe n, right, dx, so when you integrate this, you're gonna do the following. You're gonna have k, and then you're gonna have x to the power of n plus 1, all this divided by n plus 1. Guys, just in case these formulas you don't know them or you want to know more about them, I've made videos based on each of these, you can go and watch them on that icon there or on the description. I will leave those videos, guys. You can also go to the playlist and watch those videos. So let's not forget this is plus c. So let's do this. So we can say plus here, right, and then we say x to the power of, remember, n plus 1. So it's going to be negative 1 over 3 plus 1 divided by the very same thing that we have here, which is going to be negative 1 over 3 plus 1. Alright, so from here we are simplifying further. So let me create space here so that you can able to solve this problem here. Alright, let's continue. So this is going to be y is equaling to simplified. So there's nothing we can do, just rewrite it the way it is. We have 3 here. What is natural log e? The natural log e is equaling to 1, just in case you didn't know this guy's name. So this is going to be 1. And then let's look at this one here. We have 3 divided by 3, they're going to give you 1, and then you're going to be left with a to the power of 3x on the numerator divided by natural log a. Right, so we come to this one here. This one, in fact, there's nothing you can do, you just write it as it is. 2x divided by 2 natural log then 10. Now this one here, guys, as you can see, let me just say plus. First of all, if you use a calculator on the denominator, you're gonna have 2 over 3. But then if you have 2 over 3, that is, what is 1 divided by 2 over 3? This is what you're going to have, guys. 2 over 3. You can rewrite this like that, 3 over 2. So we can say this is 3, and then we have our exponent there. What is negative 1 over 3 plus 1? It's going to give us 2 over 3. So it's going to be 2 over 3, and then divide by 2. Alright, plus c. As for this one, guys, I understand some of you might get confused, but when we have 1 over 2 over 3, the 3 will go to the numerator and 2 remain on the denominator. So that's what we did here, guys. I hope you understand how to do this one, guys. Really, it wasn't difficult. It just needed you guys to pay attention to certain things that you might not be familiar with. But other than that, you must know how to use the integration laws for each term here, the power rule and the exponential one. And guys, if it so happened that this video managed to help you, or this question managed to help you to understand this type of questions, don't forget to like, and also don't forget to share the video. If you haven't subscribed to the channel, subscribe to the channel. We really appreciate that. And if it so happened that you didn't understand, you can also leave a comment, or you can rewatch from the beginning of this question. Alright guys, so we are done with 5.3. How about we do 5.4? Let's look at 5.4. As you can see, also 5.4, they want us guys to simplify the following. So I'm gonna copy this one here and paste it somewhere where there's spaces, and then we do it. Alright guys, as you can see, this is 5.4. so they want us to simplify the following here. So guys, before you simplify this one, you need to notice what is cos squared x minus sine squared x. So this is actually the double angle identity. Just in case you don't know much about double angle identities, I've made videos on double angle identities, how to derive them. So you can go to the description and watch the video there. I will leave it there, and also the icon will pop up on your top right. So this here, guys, is the double angle identity for cos. Remember guys, when we simplify, we always leave the sigma here, right, and the dx. So this is gonna be cos 2x, if you still remember, guys. Then this is gonna be that, and then from here, that's when we're gonna start to integrate. So the general formula, if you are given something like this, k, and then we have cos, then we have nx, and then they say integrate this one here. Do not forget that the integral is gonna be k, and then what is the integral of cos? Is gonna be sine nx divided by n plus c. Remember, whenever we are integrating the trigonometric ratio, we always divide by this end here, the coefficient of x. People tend to forget that. So let's integrate this one here. So this is gonna be, what is our k? Our k is 1, so even if you don't write it, it's fine. So you're gonna have sine 2x divided by 2 plus c. Don't forget guys, we are adding plus c because these are indefinite integral. So guys, this is how you actually do 5.4. They knew that this question here can confuse you. The integration and the differentiation of cos and sine, they are very confusing. So you must know your story here guys, right? So I hope this question was very useful to you to understand how to integrate this one here. If it did help you, do not forget to like, comment, and also share the video. And also you can subscribe to the channel if you haven't subscribed. Guys, this is the end of the question 5, and also it is the end of the entire question paper, the previous question paper from November 2023. I hope this video helps you to understand how to solve this problem here on this question paper. And if you want to watch more videos on these question papers, previous question papers, you can go to the playlist. There are playlists for each and every question paper where you can watch the question or the entire question. Alright guys, at the end of this video there will be other questions as a playlist. You can go and click on that playlist and watch from question 1 until question 5, all the entire question paper. Thank you very much guys for watching. Until next time, do not forget to like, subscribe, share the video. Cheers.